Hello everyone joining us from around the world. Good morning, good afternoon, and good evening. So welcome to our work Flows.All-Scenario LiDAR Solutions live from GreenValley International. I'm your host, Louis. So over the next section, we will be showcasing GreenValley's flagship LiDAR products through detailed product introduction, real-world field demonstrations, and plenty of interactive Q&A with our technical expert and account manager, Cody. So we'd love to hear from you in the chat. Tell us where are you watching from and what industry and applications you are most interested in, and power lines, forestry, mining, HD mapping, anything goes. So before we get started, make sure you follow us on LinkedIn and YouTube. That's where we share our upcoming webinars, case studies, and behind the scene RD stories. So if you are watching on YouTube, please hit that subscribe button, and on LinkedIn, click follow so you can join the discussion and get notified about our next live demo. So before we get into the product, let's start with a quick introduction of GreenValley International. GreenValley International, headquartered in Berkeley, California, was founded in 2012 by a team of global experts. We specialized in LiDAR technology, integrated GNSS, INS, NAM photogrammetry, and other advanced technologies to deliver one-stop spatial sensing and intelligent solutions to clients worldwide. And we committed to high accuracy, high efficiency, and user-friendly design. Our integrated LiDAR solutions serve industries from power, forestry, and to mapping, disaster response, and anything goes. And our journey of innovation from 2012 to 2015, GreenValley International officially established, and the LiAir series debuts with first product release, and we release LiForest software, which is predecessor of our LiDAR 360 software. And from 2016 to 2021, our rapid growth period, we released LiDAR 360 software, the LiPower software, and we developed the LiMobile hardware successfully. And we also released our LiBandpack LiDAR system, and launched the LiAir X, the world's first intelligent power line following scanning LiDAR system. And from 2022 to 2023, we opened our Japan office to accelerate the expansion of the international market. And from 2024 to present, the GreenValley Suite version 8 officially released, and we also released our M2, H600, X4, and our O2 Lite. So the journey has been one of continuous product evolution and growing recognition from the industry. So what makes us different? From a small research-driven startup in 2012 to a trusted LiDAR solutions provider in over 130 countries, GreenValley has consistently delivered innovation. So we have our from all-scenario hardware and software LiDAR ecosystem. From hardware side, we have our handheld slim laser scanning system LiGrip series. We also have our airborne laser scanning system LiAir series, and our mobile vehicle-mounted laser scanning system LiMobile series, and the terrestrial scanning system LiPod. Also, the LiGrip and the LiBandpack system are designed for the agriculture and the forestry industry, as well as the LiProtect system designed for the power line industry. And we also provide the end-to-end workflow. These are our self-developed softwares. Our LiDAR 360 software is point cloud and imagery precision platform, and our LiDAR 360 MLS is designed for the 3D feature extraction and the intelligent analysis. Also, our LiPower software is designed for the power line industry. Also, we provide the online platform. For example, our LiShare is our data publication and share platform, and our LiAR is the powerline industry 3D data management platform, and our LiCloud is data and device management cloud-based platform, and our Light inspection is designed for the real-time defect recognition in powerline industry. So behind our innovations in world-class team, our founder, Dr. Guo, is a PhD from UC Berkeley, former full professor at UC Merced, and he published more than 160 SCI papers, and he also ranked among the world's top 2% scientists by Stanford University, and we also trusted by governments and enterprises in the US, UK, Japan, and China. And our team member, so far we have more than 400 employees, like with 14% focused on R&D and technical development work, and many with master's or PhD degrees from top universities. And our mission is to become the world's leading AI geospatial company committed to advancing sustainable development for humanity and the environment. Today, GreenValley's solutions are used in more than 130 countries and regions, with annually compound growth rate 15%, and our flagship LiDAR 360 platform has more than 117,000 downloads, and from our proven application across more than 10 industries, from national power grid inspection, agriculture, forestry industry, and our mapping, anything goes. And last, don't forget follow us to get the latest news from GreenValley International. And next part, let's start with our airborne flagship, the LiAir series. So LiAir series is an air-powered LiDAR scanning system product line designed for the high precision aerial mapping. LiAir is ideal for powerline inspection, forestry, and large-scale terrain mapping. To guide us through the details, let's welcome Cody, our customer success manager. Welcome, Cody.
Thank you, Louise. Still the same page.
Switch your PowerPoint. LiAir series.
Good to go?
Yes.
Hello, everybody. Thank you, Louise, for that great introduction to GVI. All of our actions over the years have led to this moment. Again, my name is Cody McCall. I'm the North American Operations and Customer Success Manager for GreenValley International, and I have the pleasure of introducing our products and also hosting our demos. So we'll start today with our LiAir X series and our LiAir H series. One designed for autonomous flight, one of them designed for survey grade LiDAR systems, both of them capable of amazing things. Starting with our VX series LiDAR systems, we released our LiAir V40, V70 prior to 2020. Around 2022, we released our LiAir X3 and X3CH, and now 2024, we have released our LiAir X4. All are considered to be short-range LiDAR systems with a max range of around 300 meters. all designed for lightweight drones with payloads less than 3 kilograms. Our product roadmap, from tools to agents: scan, understand, and decide. Our X4 has capabilities in the level 3 to level 4 autonomous driving levels, both designed for higher integration and richer features. Starting with our H series product positioning, it is designed for medium to long range LiDAR systems, up to and greater than 300 meters, designed for medium to large UAVs with a payload capacity greater than 5 kilograms. It is designed as a high precision professional LiDAR system. Lightweight, higher integration, and high cost effectiveness. We have our H1500, our H1800, our H800, and now just released our H600. Starting with the LiAir X introduction, we have our LiAir X4, 4th generation X series autonomous flight LiDAR system. It has a 360 degree by 270 degree omnidirectional scanning capability, autonomous obstacle avoidance, airborne and handheld dual operation mode. Some of the key factors about these systems is that they have the ability to be GNSS and antenna-free solutions. Installation is simple, precision remains unaffected. So no need to install external antennas for your M350, M300 RTK aircraft. Post-processing can then generate a centimeter level high precision point cloud. The key also is the multi-platform. So having a standard or a panoramic handheld kit option has been one of the pushes over the past. Our standard kit weighs about 1.7 kilograms and our panoramic kit weighs about 1.9 kilograms. The panoramic camera comes with two 12 megapixel cameras and a battery life of around 2.5 hours. The mapping principle for these is pure SLAM or PPK SLAM. As we can see on the right, we have very extreme precise coloring, centimeter level fusion with the data scanned by airborne platform and handheld platform, and then coupled inside of LiDAR 360 MLS's new Gaussian splatting module, you can get a true scene of anything that you scan from above and below. Some of the factors of our system and our software being an encompassed ecosystem is we have our GreenValley LiPlan app. It allows for clearly viewing the surrounding environment and better evaluate point cloud quality. Allows for access to the downward facing 720 30 frame per second video stream and true color point clouds all in real time. The X4 allows for autonomous flight functions. Utilizing our AirPilot algorithm, we can do autonomous line following from above, we can do side power line following from the side, and also real-time terrain following, all using the LiDAR system as its obstacle awareness. It allows for highly automated to improve operational efficiency, lower operational difficulty to free up drone operators, and product business deep integration. The autonomous line following flight allows the aircraft to operate above the power line and towers, keeping a consistent elevation and following the conductor's path. This single system allows for autonomous fork identification, autonomous turning, and autonomous crossing of overhead lines. So power lines at centimeter level, also allowing for tree precise identification, allowing for crossing, traversing, and safely circumventing any type of power line that may be a scissor crossing above or below the focused power line point. A single inspection flight gathers multiple data outcomes, including point cloud and tower images. The LiAir X4 device is, when equipped with the H20 or H30 series cameras, can autonomously recognize transmission towers during the online path following process. It captures images from the front, above, and behind the towers. Years of expertise in the processing LiDAR data for the electrical power industry has led us to be able to support the export of hazard point files and tower ledger sheets in real time. This feature addresses the needs of on-site personnel to quickly review hazard point information following field operations. As we can see, we have Excel sheets that are generated in real time, allowing for the exact tower number, the longitude, and the height of the system, also indicating by danger points and distance from those danger points. Our side power line following flight allows the aircraft to fly parallel to a single phase power line at the same altitude. This technique offers high stability and allows for the inspection and photography of potential issues such as unraveled strands on the shield wire, floating debris on the line, and burn marks from the obstacles causing discharges below the lines. So no need for manual control or pre-planned inspection routes. Identify and lock onto the shield wire from multiple angles, including from above, below, and directly alongside. It supports autonomous switching between multiple phase conductors and also supports continuous flights along the same phase line, automatically navigating around towers safely. The system also allows for spacer bar photography, supporting real-time identification of spacer bars during the flight. Captures images of spacer bars from the 3 positions, front, middle, and rear, to get highly detailed images of the bars for further analysis. Continued, we also allow for the ability to support real-time extraction of catenary sag during the flight, along with capabilities to view and export sag reports directly within the flight control software. Giving you these detailed reports in real time, again, allows users in the field on site to analyze the sag in real time. Another cool feature with the system is that it allows for real-time terrain following without the need of a DSM, which means a user or a pilot can show up to a location unknown to them before and launch the system and automatically autonomously follow the terrain. It uses the LiDAR for this in order to be able to safely maintain the same altitude at all times without a previous DSM or knowledge of the site. Some of the key product parameters behind the LiAir X4 is its extreme lightweight of 1.4 kilograms, a system accuracy of plus or minus 5 centimeters at 100 meters, also utilizing the XT32 M2X with a range accuracy of plus or minus 1 centimeter, allowing for up to 1.92 million points per second at triple return. Our camera is a 26 megapixel camera with the 16 millimeter focal length, allowing for very clean and clear, crisp images for detailed analysis. Moving on to our LiAir H introduction. Our new LiAir H600 is the next generation lightweight mid-range LiDAR system. It utilizes a single line high precision laser sensor, an all-in-one design with deep sensor fusion, compact payload rotor drones capable of doing large scale mapping. Some of the core parameters with this system is that it is lightweight, accurate, and long range. The total system is about 1.3 kilograms with a detection range of between 10 and 750 meters at 80% reflectance. The system allows for a 5 millimeter at 100 meter repeatable accuracy and a thickness of a point cloud under 3 centimeters. High precision and fine mapping LiDAR, exceptional point cloud performance. Data reliability is the most fundamental yet critical requirement. So this system allows for a 0.5 milliradian ultra-fine spot size, repeatable accuracy of 5 millimeters at 100 meters, which means we have high accuracy and repeatability versus a high accuracy and low repeatability, meaning that the system is going to continuously give you the same results, which are reliable and repeatable. Again, the high precision and detailed is realized when you have a point cloud thickness better than 3 centimeters at a high altitude. With an elevation accuracy better than 5 centimeters at 200 meters, we are able to maintain this level of repeatable results and stand behind our systems. Some of the other neat factors about the system is the unlimited echo returns with strong vegetation penetration. So you can obtain more complete and higher density terrain data under forest canopy. With a small spot size, high energy, superior ability to penetrate gaps and pass through holes, it allows us to see what we see on the right-hand side at 200 meters above ground level. We have a very strong, detailed ground analysis, visualizing using 7 returns. Even at 300 meters above ground level, we still have a very detailed ground analysis, which will lead for very strong DEMs or DSMs and bare earth models for future survey purposes. Some of the key factors is an adaptive configuration of operational parameters for a more uniform distribution of point clouds, more precise reconstruction of 3-dimensional spatial features of ground objects, 7-level flight altitude laser scan rate repetitive configuration scheme, as we can see on the right-hand side, based on the altitude, the speed, and the rotation speed. The scan line spacing and point spacing are always consistent, resulting in a uniform point cloud distribution. As we can see, the line spacing is equal and apparent with the point spacing. allowing for a very detailed result, as we can see on the bottom left-hand side of the screen. As I mentioned earlier, when the system is coupled with LiPlan GreenValley app, we have an intelligent flight control mode, which ensures the integrity of the surveyed area while minimizing the data redundancy to maximize extent possible. This software, when put onto the remote, allows for real-time 3D point cloud visualization, camera video stream, allowing the intelligent flight control mode to automatically start data collection upon takeoff and stops data collection upon landing. Some of the key product parameters with the LiAir H600 is also its lightweight, 1.3 kilograms, a system accuracy of plus or minus 5 centimeters at 200 meters, a weather rating of IP64. It utilizes a sensor that's capable of ranges from 10 to 750 meters at 80% reflectivity. With the unlimited waveform return, we see up to 550,000 points with a field of view of around 80 degrees. Utilizing the same camera as our LiAir X4, 26 megapixels with 16 millimeter focal length. Some of the solutions and the way that we go about making sure this data is the way that it should be is our data acquisition and processing workflows. So starting with the data acquisition, you have the system and the drone coupled with the GreenValley LiPlan app, allows for our terrain following or power line inspection depending on the LiAir product. Then in the pre-processing phase, we have our self-developed LiGeo reference and LiDAR 360 MLS BP when using the handheld kit. It allows for one-click process of POS, georeferencing, smoothing, and colorization of your data, all with a simple one-touch operation. And then the final analysis for the post-processing side can be done inside of our LiDAR 360 suite or LiPowerline for data fusion, feature extraction, vector editing, and industry-specific applications. Now we will move on to the live demo, and Louise will accompany me with that.
Okay, Cody, seeing is believing. Can you walk through with a live demo of the LiAir X4?
Yes.
Yes, let's go. Director, please switch the camera to the demo area. Let's go. This is X4, right?
Yes, LiAir X4 with a spider. Okay,
Cody, let's install the system, or you want to introduce it briefly?
I'll start to install it and also introduce it at the same time.
Okay,
so again, extremely lightweight, omnidirectional spinning LiDAR head. We have our 26 megapixel camera. We have our SD drive with a USB-C slot. We have our power port, our GNSS port, and our on-off switch. Traditional Skyport mounting setup. We will align the white dot with the red dot, turn, and now the system is locked in place. From there, we'll go ahead and attach what is called the OSDK cable to the system. Now we have our completed system ready to go.
Very easy.
Super easy, super simple, 2 seconds of time.
Yes.
From there, what I'll go ahead and do is power on the device. First, the drone. The drone will do its first self-checks. It'll give a notification of boop, boop, you know. And then from there, what we'll do is we'll go ahead and power on the device. The drone has completed its power on sequence. So from there, I will go ahead and select on the power button and hold it for about 1, 2, 3 seconds. And then we have a start of a red flashing light here in the indicator, which is indicating that the system is going to do a self-check. And as we can see, it did one full 360 degree spin, ending right back at the location that it should start at every scan.
Cody, why there's no antenna installed?
Yeah, so one of the cool features about our new LiAir products is that they have the capability of being GNSS antenna free. It utilizes the RTK from the drone itself, allowing for precise measurements and PPK processing.
Perfect. And how is the collected data saved?
Yeah, so in the system there is actually a 256 gigabyte SD card along with the 512 internal storage drive.
Internal storage?
Yes, so it allows for the data to be stored internally just in case that the SD is damaged or by some chance you happen to forget the SD. It is stored internally as well.
Perfect. And what is OSDK cable used for?
Yeah, so the OSDK cable is used for communications, and it's what allows us to take full control of the drone, allowing the LiAir X4 to autonomously navigate safely.
You mean the powerline following function and other like terrain following function?
Exactly.
Is the OSDK cable connected?
Exactly, yes.
Okay, right, I got you.
And so one of the key functions is that we have an indicator light that while it's going through its self-check, it's flashing red. When the system has initialized and gone through its self-check, the system will indicate a solid green light, letting us know that the project is ready to go and we can begin the start of the project.
Oh, okay.
We will actually start the project from the remote.
Oh, maybe we can check the remote?
Yes, we can check the remote. As we can see, the light is green, and we'll also see the indicator on the remote over here.
Okay.
Here with us today, we have a licensed pilot who is going to be handling the flights for us. So as we can see on the LiPlan interface, we have our FPV facing from the drone itself, and then we also have the payload camera, which right now is dark because it's so close to the ground. From the top right, we have the device connection. So the blue pause button is indicating that our LiAir X4 has been connected. We have all the basic parameter settings that you would on a typical remote, allowing for visualization of the battery, the RTK status, the remote status, the device settings, the satellites. On the bottom hand side, we can see a real-time map. We see the height, the vertical, and the standard deviations. And then we also have the system status. So we can see GNSS, camera, PSDK, OSDK, and laser are all green check, ready to go. And then on the right-hand side, we have start the project. So from here, what we're gonna do is go ahead and hit start the project. What this does is now the system has begun to spin, and it is starting to collect. Within a few minutes, we will start to see a real-time point cloud as soon as the pilot goes to take off. So what we'll first do is double check to make sure all the parameters are set up for us to do this above line following of a distribution line. So from top to bottom, we have the inspection mode of both above and side. We have the power line type of distribution and transmission. We have the distances away from those objects to make sure that they're safe. We have the set flying speed, which for this will be 4 meters per second, a clearance distance of objects of 3 meters. Switching the mode between app and remote control just gives the remote more actions instead of just operating on the user interface. If the device by chance loses control of the signal, we have it set as either hover, continue flying, or safely return home. We have the setting for taking tower pictures, which is more designed for the side following, which will allow you to open or close that. And then we also have our turnaround mode.
What's the turnaround mode logic?
Yeah, so the logic behind that is that in the turnaround mode, in distance mode, we can preset a specific distance that the drone will fly. Once it reaches that distance away from the remote, it'll safely stop the collection and return home. Or there's the tower mode. The tower mode allows us to preset a specific amount of towers. It will scan those
specific tower numbers.
Exactly. So in this case, we chose 8 towers. So it will do a total of 8 towers. And at the end of those 8 towers, the device will automatically turn back around and fly the same path that it flew on the way there, returning home safely.
Okay.
So from now, we'll go ahead and start the device and allow it to take off. So now we have the drone slowly ascending just so that we can visualize the real-time point cloud on the right-hand side. If we were to click on this real-time point cloud, we can bring it up to a full-size view. This also allows us to adjust between the real-time colorization and the other type of elevational colorization or intensity for a brighter view. In this case, we don't need to worry about that right now. We'll go ahead and go back to the main flight mode. Now the pilot will go and fly to the location of the power lines themselves and locate the first tower that we plan to follow.
Back to the device, does the X4 require warming up or figure 8 calibration before flight?
No, actually, that's another beauty about the system is that it is good to go. As soon as the system starts the project, you can take off and fly to the location.
Really?
Yes, and it maintains the same level of accuracy.
So during line following, must the drone fly directly above the power line?
During the line following, the system actually locks onto the line, and in preset parameter settings, you can have the horizontal offset at 0, which would be directly above the power line, or if you would like to have it slightly off to avoid any type of objects of nature, you can change the horizontal so it'll stay 2 to 3 meters or so away from that original 0 point.
Gotcha.
Transmission signal is temporarily unstable.
And that indicator that just highlighted, that is purely based for the real-time point cloud, so that may cause a slight delay, which will catch up in visualization purposes. And as we can see, it's a beautiful, very hot day. So blue skies and some green fields. This is a really, really nice spot to scan. We got a lot of different types of agriculture and also a lot of different types of power lines that we're able to do this demo with. So as we can see that we are slowly starting to approach this distribution line. What the pilot is going to do is locate the first tower, hover above the tower, and then we'll walk through the phases of beginning the initial collection. Okay, so now that we have found ourselves over the power line, what we're going to go ahead and do is adjust the settings so that we can start the automatic line following. So by clicking into it, we now have an option on the right hand side that was previously grayed out that says Start Auto Flight. So the pilot will go ahead and select the Start Auto Flight now that we are above the tower, and the system will begin to identify the power line. From here, what we're going to do is see the parameters designed for us to make sure that all is good. If we wanted to, we can import a KML file in advance, and we would select tower import information. The turnaround mode at this point is set for distance, and we are going to choose tower numbers. So a preset number of 8, and we have our loss control mode to hover, and then everything else is your common base settings. From here on the top left-hand side of the screen, we can see that the device says identifying power lines. So what it's going to do now is identify. It has now locked onto a power line, indicating the channel buffer width that it will be following while doing this autonomous power line following. Straight. So it said that it detected a crossing, that we will go ahead and allow for the straight flight of this distribution line.
For the line benching, must the pilot manually choose the path?
No, so if we were to preload a KML file into it with those branches, the system will automatically follow the KML file as needed.
Okay.
And so from here, as we could see from the pilot, we have our FPV that is now starting to see this transmission line that is crossing. It says indicating autonomous power line flying while still maintaining the safe distance above the distribution line. Now we have an indicator saying that there is a crossing overhead, and we are going to choose to follow this directly and follow as needed and run. So the pilot hit the top one, and now it's going to safely follow this system and actually determine to follow, fly below this power line because it is detected that the distance is safe enough. Oh, it's actually deciding to go over this one. So
how does the system handle crossing spans automatically?
Yeah, so in this case, it determines the distance between the power line and the device itself. So the overhead crossing line, if it is within 7 meters, it will determine to cross over it safely. If there is objects or obstacles below the power line that may determine whether or not it shouldn't cross underneath, it'll always choose to go above as a safe method. But if it sees that it is safe to fly under, it will actually fly under if the power line is above 7 meters. So now we have crossed the power line itself, and we're about to descend back down to the safe distribution route. And as we can see on the right-hand side screen, we see a bunch of red dots that are being highlighted. Those are actually the real-time danger points that are being highlighted, and we can see them here in the danger point list. So he just refreshed the list to make sure that we see the most up-to-date result from these real-time points. And now we can see, as we view this, the points and also the towers. So along this route, we can see 2, 3, 4, 5, 6. Those are actual tower locations. And then the red dots are indicating our danger points, which would be, in this case, trees that are close to the distribution line. Again, now we can visualize in elevation, which gives us a little bit better of a clear image. We can see the power line is highlighted in yellow of the distribution, and then the transmission is in red because it is much higher. And so now the system is indicated again that there is a line where it cut off the chute. So what we'll do is we'll come back in and we'll exit this, and we can see that the system has reached the 8 tower point, and now it's going to safely head back home. We still have our view within that channel buffer, allowing us to change between the FPV. Now what we're doing is heading back towards the same transmission line. This is again highlighting the safety side of the device, designed to automatically come back home based on its known path that it has already taken.
Come back home in the original routes?
In this case, we have it set to hover at the end of the flight. So at the end, it's going to hover. But if we wanted to, we can have it come back home. But in terms of the power lines that it followed, it will always follow that original historical trajectory. So again, we reached this transmission line, and it has determined that it is safer to fly over the crossing lines than it is to fly through them. So we will, or below them. So this same one will cross back over, and then it will safely fly past, and then come back down and fly to that final point. We have a very detailed view now of the system itself. So we can see as we're crossing this transmission line, we have a very clear, very detailed visualization of both the shield wires, the conductors, the distance from the system itself. And we can see there's operating vehicles below us, and safely we are still maintaining the distance needed. Now the device will begin to descend and continue along its original flight trajectory.
The video transmission signal is temporarily unstable.
If vegetation blocks the lines, can fly following continue?
Yes, so say you have a situation where there is branches that are over the line, the system will continue following in its historical trajectory, meaning that it will follow the same path it had already been following to determine to go past it. If the trees are high and blocking it, it will safely fly above them and go past them in order to maintain that historical trajectory, similar to the transmission crossing.
Got you. I hear the voice.
And as we can see, the system is now continuing back down that same trajectory, which allows us to feel comfortable knowing that our device is following what we wanted it to do, and that the pilot can rest assured that they're doing it safely.
The video transmission signal is temporarily unstable.
So now we are passing Tower 2. We're about to come up on Tower 1. It's reached its starting point. So what we'll do is go ahead and call the drone back to the home point. So as we can see that the drone is now heading back home safely with its chase pilot. As we can see, the X4 is still rotating as it comes back home. After the device has safely landed and the props have shut off, we will go ahead and end the project on the remote. Same button.
Close the project,
Yep.
right?
Yeah. So what we'll do is say start the project, and now it will end the project collecting, allowing the device to stop spinning, which means that that data has now been saved inside of the device and on the SD card.
Okay.
From this point, what we're going to do is come on over.
Yes, the X4's above line following function is completed. What's
Yes.
the next part, Cody?
Yeah, so the next part is after the above line following, we're going to highlight the side power line following.
Side power line.
Yes, so what the system does is it stays locked on at a parallel rate and flies parallel to the power line to get a very detailed image analysis using the H20. In this case, H20, H30 is also an option as well. This one allows for RGB and also infrared. So the very first thing that I'm going to do is go ahead and power off the LiAir X4 by holding it for 3 seconds as I did previously. So now that I've held it, the light is flashing red. This is an indicator letting us know that the device is shutting down. The device also produces a slight hum, which is just the processor inside operating. Once we hear that hum stop, we know without visualization that the system has stopped. Now what we'll do is we'll go ahead and power down the drone. Again, this is all just safety features. We're designed to make it so that you don't disrupt or cause any type of power shortages by disassembling the system while it's powered on. This would also be a good opportunity to change the batteries if needed or do a hot swap if needed.
Yes, let me check.
Okay. I think they should be fine.
Okay, and then you can install the H.
Yeah, we should
Enough?
Yeah, we should be good.
Okay.
Three bars, we should be good.
Okay.
So in this case, what I'm going to go ahead and do is install the upward facing gimbal. We have 4 mounting points on the top of the drone itself. So just 4 thumb screws that allows for easy, quick operation. Once we get these in here very tight, we'll go ahead and plug in the PSDK, allowing us to have the visualization of the H20 in our LiPlan app. So from here, we'll go ahead and take the H20, and as always, we'll go ahead and line up the white with the red and slowly twist it to the left to make it so it locks in red on red. Now the system is set up and ready to do the sideline following. We'll just do some checks to make sure everything is good, props are good, line's tight. So from here, we'll go ahead and power the device back on. So the H20 is doing its self-check, same as before. We'll let the drone do its self-check. Burr, burr, burr. Now we'll go ahead and power on the LiAir X4.
And
1, 2, 3.
Do the self-check too?
And our device also does the self-check. So right now it's about to spin a 360-degree spin as before, allowing for it to come back to its original point, making sure that it always starts in the same position. At that point, the light is also flashing red, doing its self-check, which it's checking GNSS, it's checking the LiDAR calibration, the INS is communicating correctly to make sure that each flight the system operates the same as it would on your previous operation.
Well, we need H20 camera in our side power line.
Yeah,
inspection?
so in terms of inspection for side power line, it gives us very detailed RGB images of the tower itself, allowing for us to identify issues such as unraveled lines, issues in the line itself or in the spacer bars, issues in the insulator. All of that can be highly detailed using something like the H20 when coupled with the X4's autonomous capabilities. So now that we have the system operational and ready to go, we'll move back over to the remote and see how the interface looks.
Okay, let's go.
Okay, so now on the remote, we can see that there's a slight difference. in the layout. And so we're waiting now for the device to connect. If you ever run into issues, just a quick refresh always helps. IT 101, did you reset the device? Yes.
Agree.
So now we can see that the system is fully connected. All system status indicators are okay and green. The key difference that we see now is there's multiple functions on the left-hand side of the screen. We have the H20 visualization, zoom, infrared. We can see everything that's going on now, including the FPV. Now we have the inspection configuration pulled up already. Previously, we were set in the inspection mode of above. This time, we're going to go ahead and change it to side. And here we can adjust the voltage. So in this case, we're going to be flying a 220 power line. So we'll set it as 220 and okay. And then from there, everything is going to be roughly about the same, except for the vertical distance stays at about 0. And now the horizontal distance is 7 meters away from the line. So it safely follows the line at 7 meters. The working mode is the same. We have power line and tower mode. So power line mode and tower mode allow for a difference in functionality between the system itself.
Hey, Cody, what the span mode and the tower passing mode mean?
Yeah, so span mode or power line mode in this indication is that the system will go to the line, and in many situations you have multiple levels of lines per span. So a span mode keeps it within the span, which means it'll do one line, fly down safely to the next line, and then come back, and then the same and back. So say you have 3 lines, you'll have 3 trajectories on each line. If you choose the tower mode, what it'll do is choose the one conductor and just continuously fly past the tower itself. And so in this case, we're going to do a similar function. We'll go ahead and start the project. From there, our device has now began to spin, and the pilot will go ahead and take off, and we will go to the location and lock onto the tower itself.
Now can we take off?
Yes. So at this point, everything is pretty much the same. We still have our real-time point cloud visualization on the right-hand side. We have our real-time map. We have all of the indicators for the actual drone itself, including its bearing, the altitude, the original location from home, the speed, the velocity. So right now, the pilot will fly to the location.
So what voltage levels does X4 support?
Yeah, so X4 side power line following supports 110 kilovolt up to 500 kilovolt lines.
Can you switch the camera, the layout? We can see the RGB camera or infrared camera.
Yeah, so as of right now, we have our FPV, and if we switch, we have the zoomed in from the H20, we have the wide angle from the H20, the infrared from the H20, and then also our payload camera as well. So we have 5 different views when utilizing the side power line with the H20 camera.
So for one flight, we can get infrared data, RGB camera data, and point cloud data.
Yes, so you can actually choose which ones you want it to save. So we have data record, starting collection, so we can choose the different types of data that's stored and how it's stored prior to the flight. So I should have done that in the beginning to show you that. There's check boxes that allow you to choose which ones you want it to store and save. If you want to save space size, then you can just do RGB. In this case, we chose all of them. So right now it will store files for all of them.
Okay.
And now the pilot is safely approaching the pylon itself, looking to locate the first line, the first conductor line, finding that spacer bar in the middle. And so from there we have the FPV view. So what he's going to do is safely navigate the drone to face in the direction parallel to that of the power line. From there, we are safely away from the power line itself, and we will go ahead and begin the start auto flight. And same situation with this, we don't need to mark anything. We are ready to go. So we hit sure, ready to fly. So now the device is going to identify the power line similar to that of the above power line, but now it's identifying it to the left. And so we can see that the device is still indicating that it is looking for the power line itself. So the pilot may move it to the left a little bit, just to get a little bit closer. And so right now it's still identifying the power lines.
Power line is detecting. Start adjusting the distance from power line.
So now we can safely move a little bit closer.
Video transmission signal is temporarily unstable.
Because right now it's indicating that we're about 8. We should be at about 7 meters. It should be able to detect, but in this case, just for time, we'll go ahead and make sure that we detect it clearly. So we'll get a little bit closer. So as we can see on the top of the screen, we can see it says line distance. Right now we're about 8.5.
Power line is detecting. Start adjusting the distance for power line.
Okay, we can see that it's starting to get a little bit closer. So what we'll do is we'll zoom in. So what we first did is autofocus on the line itself. Now we're just making some final adjustments just to make sure that it safely locks onto the power line.
Power line is detecting. Start adjusting the distance from power line. Power line is locked. Finish.
There we go. So now that the device is locked on, it just needed to be within that 7 meters. And so what we're going to do now is adjust the frame rates and the focus of the camera to get a very detailed image of the camera, because this will be the focal length we choose. So we'll choose autofocus to make sure that it clicks on it. We'll click there to make sure it targets the line. And then we will preset it back to manual focus so that it locks in those lines. And we have a setting over here on the left-hand side that allows us to see how far away the device is from the actual line itself and what it's seeing. We have our line, so we'll turn that off. And then we have a virtual disc on the left-hand side of the device, which allows us to move up and down. So the pilot went ahead and clicked start, which what it's doing now, we can hear the camera triggering, and now the device is autonomously following the power lines at that safe 6.5 to 7 meter range.
So now the device are taking pictures.
Yes.
And scanning the lines automatically.
Exactly. So it's automatically taking pictures at a specific distance preset, and then it's also following along the line at that specific set distance in advance, maintaining that level so that it safely keeps its adjustment from the line.
If I need to temporarily stop the line following, what should I do?
Yeah, so actually to temporarily stop it, you can just press the pause button up at the top left-hand side of the screen where it says autonomous power line following. It'll temporarily stop it. and you can resume the collection after that by pressing play again, or you can return home safely in case there's an emergency that may arise.
Yes.
And as we can see on the right-hand side, we still have our visualization of the point cloud in real time, so that way we know what the device is following, along with obviously seeing the images on the remote itself. And as earlier we mentioned, there was a span mode and a tower mode. So as we begin to get closer to this next pylon, an indicator will pop up that will say creating new folder. What that's doing is that it's separating the files and allowing it to have one file of images per conductor line. So now as the device decides to go down and connect to the next line, it will create that next folder so that you have in this case, three separate lines to follow.
Just for the image.
Just for the
data.
images, yes. The point cloud is in one file format, which is saved onto the device, but the images are separate. So. And now we will go ahead and return home after this. We got our indicator of 25%, so we are safe enough to be able to fly home.
Yes.
So you're good to fly home, and we'll go ahead and bring the system back to us. And so usually with DJI, the indicator is about 20% when the device says that it should be time to return home. We put in our system 25% just to make sure that there's enough time coverage to be able to make it home safely, land, store the data.
Yes.
We wouldn't want the device to the drone to die and not be able to store the data. Collectively, it's just an extra safety precaution. So.
Yes.
And it is possible, so for the demo purposes, we decided to split those two different flights. But it is possible for the pilot to be able to set up the H20 right away, go and do a distribution line, and then directly go and do an above line of a transmission or a side following of a transmission and process the data separately, so that they can save time in the field and it would be a larger data set, but they can do that.
Yeah.
We always suggest coming home, landing, starting a new project, just in case there's any issues. But if they're tight for time, then they can go ahead and do that.
So I can install both X20 and X4 and perform the above and side line following?
Exactly, yes. And so as we see, the drone is coming home safely. So we will go back out there.
Okay.
On the remote, he will go ahead and end the project just like we did last time, which will force the device to stop.
Yes. Cody, don't forget to take our newest product.
Yes, indeed.
So the autonomous live following function of X4 has completed. So next, Cody, this is our latest new product, right? Newest product, right?
Exactly. So what we have here is our LiAir X4 handheld kit with panoramic camera. It's got two 12 megapixel cameras, as mentioned before, along with our GNSS antenna built onto it, with an easy installation, a handle, and also a battery kit with a cable and a strap. So what we'll do here is go ahead and safely again turn off the LiAir X4, allowing it to fully shut down. So 1, 2, 3, it begins its clicking, and then after that process ends, we'll go ahead and power down the drone. I'll disconnect the device itself and then attach it to our LiAir X4 handheld kit.
As well as the drone? Power off?
Yes, the drone I'll power off. So the X4 has fully shut down.
1, 2, 3.
Drone, 1, 2, 3. We got the power.
1, 2, 3.
Yeah, 1, 1. Yeah, 1, 1.
1, 2, 3.
As we all know, we got that first click and then the secondary hold to make sure that the power shuts off for the drone. So what I'll do is I'll go ahead and disconnect the OSDK cable. From there, I'll push the button on the side of the Skyport to release it, turn it, and then pull it off. So now we have our device as it was, just the single device. Key factor with this is while it's on the drone, it's actually faced downwards. When it's on the handheld kit, we actually face it upwards. So then we'll go ahead, find that white spot, turn it red to red. Now we have a fixed system. We'll take our panoramic handheld kit and plug it into the back, as so. Push it in, and then tighten all of the thumb screws. What this does is locks it in place so that it isn't easily jarred and keeps the system calibrated and in functioning order throughout the entire collection.
So we upgraded the camera, so now with the handheld kit, we can achieve the colorized point cloud data with X4, as well as we can achieve 3D Gs.
Exactly. So with the new panoramic camera, before we had just the GNSS mount set up for the handheld kit.
Yes.
And one of the key things customers were asking us about was being able to colorize that handheld data set. So now the X4 has a camera which allows for extremely high detailed accuracy, along with being able to produce 3D Gaussian splatted models directly from a handheld device that is actually an aerial device.
Yes.
So the key part about it is it's light, it's easy, quick and easy to go. So this would be the entirety of the setup. If we were to do a data collection with this system right now, all we'd have to do is power on the device as we would normally, allow it to sit for just the time being of waiting for the self-check initialization. We will manually start the project, or we can do so from the LiAcquire web, which is accessed through the device's Wi-Fi.
And the workflow is similar to our LiGrip series, right?
Exactly. So the fact of the system is that traditionally on the drone, it is a INS-based system utilizing LiGeoReference for processing. But when it's put into the handheld kit, it uses our self-developed SLAM algorithms. So we always suggest to follow the same parameters as the LiGrip. In this case, what you would do is you'd power on the device, you'd let it do its self-check. Once it's good to go, you start the collection, allow it to sit for about 30 seconds. Then you pick up the device like you would the LiGrip, walk your figure eight, do your collection path, come back, walk a figure eight, and then close the project. Let it sit for 30 seconds, close the project, and then it's good to go and begin collecting your next set of data.
And don't forget initialization.
Exactly. Initialization is the biggest part, the key factor, because during that 30 seconds of just letting it sit there, it's actually creating a base SLAM map. So it knows where it's at when A occurs, so that when it gets out to Z, it knows to come back to A when using those SLAM simultaneous localization and mapping algorithms.
Okay. So I think this is the whole part of X4.
Yes.
And can you describe how to install our new product H600? I think this is also our newest product, LiAir series.
Absolutely. So again, we have our LiAir H600.
Yes.
Super lightweight. It's one of the first things that people have been noticing about the device is that it is extremely lightweight. It has our 26 megapixel camera and also a single line beam laser. This allows for very detailed, very straight lines with that continuous repeatability that we spoke about in the PowerPoint presentation.
Yes.
The system itself has a single power button for both powering on the device and starting the project, similar to the X4, as well as an SD card slot for external and external data storage and a USB-C drive.
Yes.
It also has a single GNSS mount port. As mentioned before, both of our new systems allow for a GNSS-free antenna solution. But in the case of a need for GNSS for PPK, you can also utilize our GNSS port for third-party adaptation or other platforms.
Yes, true.
On the side, we also have a 14 DC 14 to 24 power outlet for third-party adaptation. So if you have interest in doing an adaptation with your own drone, let us know and we can make that happen.
Can I upgrade the camera?
So no. So the system itself is actually fully designed as a single integrated unit on the inside. So something like a 45 megapixel camera just wouldn't suit. So it's preset as it is, but the quality of the images most clients will see is perfectly to the standard.
Okay. So let's show the installation.
Yes. So very simple, same setup as the X4. We'll go ahead and put it under, match the white with the red, put it in there, and then turn it to the right. And now we have our fixed system. This system doesn't use OSDK. It does all communication and or power via the built-in PSDK components with the Skyport.
Super easy.
Super easy. One touch operation, again, super lightweight. The range of this system is up to 750 meters. However, we suggest that 300 meters is where we can see this like continuous repeatability. So anything between 0 and 300 meters, you're going to get that high level, high accuracy of repeatable. But if you need 750 meters, the only difference is that your point density just becomes a little bit smaller.
Yes.
So nothing too big in that case.
So before we take off the H600, we need to adjust the parameters about the height,
Exactly.
the frequency.
Exactly. So the system itself has built-in parameters designed to adjust the calibration or the parameters of the system based on the preset flight altitude that we put in the system. 100 to 150, 150 to 250. The system will automatically adjust the systems best suited for that. In situations where you have very high level changes in terrain, it's always suggested to make sure that the height that you choose in the system is higher than that of the lowest point of the flight. So the system where the lowest point is, make sure that you do your measurements based on that. So say your flight height is 120 meters, but at one point the elevation puts that at like 10 meters. You're going to want to make sure that you choose 150 to 180 just to make sure that it prevents any unnecessary noise or anything of that nature.
Yes.
Again, super easy, good to go.
Yes. Maybe you can show you how to process the data we just collected.
Exactly, yeah. So previously I didn't mention it before, but at every situation when we go out to do a demo, we always set up a base station, right? So that you always have a backup PPK. Even if you have RTK at the point, it's always good to have a PPK. Earlier we had set up a base station, making sure that it was collecting throughout the time frame. Base stations can range from a Rhinex generated or a Novotel. In this case, we used the simple Novotel. So we will take that data, we'll take the base data, and we'll go ahead and run through the processing.
Yes. And one thing I want to point out is that for LiAir series and the LiMobile series, we always recommend the PPK.
Exactly.
With high accuracy.
Exactly. So for repeatable results, PPK allows you to put in an absolute point, giving you that truly trustable, repeatable result. So we always suggest PPK. We know sometimes people are in a pickle and they got to do something quick. So there is that option that they can look and view the data afterwards. But the key to get that repeatable survey grade is by having either PPK or at an absolute point or a PPP process that you do within LiGeoReference or in something like Opus.
Okay. I think that's all the demonstrations for our LiAR series. Next, Cody, can you tell us how to process the data and for some industry application results for us?
Exactly, yes.
Okay, thank you.
So we'll go back up on stage and allow that.
Let's switch to the camera to the stage. Thank you.
As mentioned earlier, it is extremely hot. So what we'll go ahead and do is open up our LiGeoReference software. So here is the user interface of the LiGeoReference software. We also have our data already transferred to the device. So the first step that I'm going to do is go ahead and select Open Project, and I'm going to select Browse. From here, I'm going to highlight what it looks like in our data after the device has been added to the system. So we have our LiAir X4 H600. And here we have some process data and then also raw data. So I'm going to walk through the basis of the data file formats and what comes from the system itself. So what you're seeing now is a automatically generated folder with multiple subfolders. This is generated as soon as you hit the start project. It starts to collect log files and save log files and store them all into a subfolder. And then you have a single .live file which stores all the metadata, allowing the software LiGeoReference to automatically grab that data. At the top, we have our base file, which we have already preloaded in a base file. We have our calibration file, which is the preset camera parameters and laser location based on GNSS offsets, which we can adjust to suit third-party drones. We have the camera, which is the images. We have our camera file, which is automatically generated and is where the images go after the process, and all of the metadata related to camera is stored there. Georeference results is where the data itself is going to be placed once the processing is done in LiGeoReference. It does this automatically. INS raw is where we have our INS related data, so anything related to the IMU and the INS is stored here. Laser raw is actually the laser's raw data stored in a compressed file format to make it easy to transfer. LiNav is a file that's generated, so once the processing is done inside of LiDAR, inside of LiGeoReference, the post-process results will end up in the LiNav. The log file is everything related to the device itself, the logging, the capturing, the time of capturing, everything related to that. And then report would be any type of report that's generated inside of LiGeoReference. So the very first thing I'm going to do is go inside of go in LiGeoReference. At the top, we selected open already. I'm going to go ahead and click the .live. From there, what we'll see is that it will automatically pull in the trajectory of this device. So here we can see we have this trajectory from the path that we had done. This is the one that is the distribution line with the crossing line and two different crossing lines. So I'm going to go ahead and follow the same steps that we always do, which is select on trajectory. I'm going to choose just one of these trajectories since there's no need to process both of them. I'll choose this top one, which includes that of the crossing line. Actually, I chose the lower one. So let me disconnect that and I will choose the crossing line. So we'll come back in here. Highlight the trajectory. We'll go ahead and follow along the trajectory. We can see as it's going, it's highlighting and selecting along the way. We'll zoom in to make sure that we still have that same line. So what we'll do is we'll follow it all the way down to that last tower. If you need to, you can adjust it to look at it from the side. All right, so I'll go here and we're gonna get it to this very last point and double click it. So now we have a separate trajectory. At this point, what I'm going to do, now that we have this trajectory selected, I'm going to go in here and look at the settings just to highlight some of the key settings. So we have the laser settings, which I had mentioned is a compressed viewpoints file. We have the camera settings, which is stored in the Cam1 folder. We have the post-process setting. This is where we would input in the INS and the base file. If we have an absolute point, we can go ahead and put it here in the manual absolute point. But at this point, we'll just utilize from average. And it is using a Novotel log base station. We have our target coordinate system, so we can choose our target coordinate system. The LiGeoReference should automatically target that coordinate system when it is brought in via LiBase or via the base file. We have classification settings, which are most optimized for power lines. And then we have external settings. So in this case, everything is good to go. I'm going to go ahead and hit OK. And then at this point, we can check post-process, georeference, and I'll go ahead and hit start. The reason why I am only checking post-process and georeference is because at the end of georeference, we can look at the trajectory reports. We can run bore sight and trajectory adjustment. We can do cut overlap. We can do removing outliers all before we do classification and or accuracy checks and colorization, just to get really, really good results, making sure that we have these strong results. But right now, to save time during the demo, because we still have a lot to show you today, I'm going to go ahead and open up LiGeoReference and open up a couple other projects. So first and foremost, I will go ahead and show this data that we just collected, but in the processed format. So from here, we have the same file. We're going to come in, and as mentioned, we have our georeference result. So that georeference result would be if I was to open it up in LiDAR 360, but in this case, I'm going to open up the .ligeo file. This .ligeo file, as mentioned, is all of the data stored and everything else that we need to see. In this case, since we have all this additional trajectory that we don't need to worry about, I'm just going to turn those off so we have a better visualization of what we focused on and the colorization and the results that we did here. So if we come in here, we can see that we got this distribution line. We have that transmission tower. We got some good vegetation going on there. If I pull up the RGB, we'll have our results from RGB with this nice clipped viewing of RGB. Got the trees, the roads. We can see the towers themselves, including the transmission line overhead. If we put this back to height, we can visualize it in this way so that we can see elevational changes. So we can see that the green here is highlighting the distribution, and at the top we have our transmission. So I'm going to go ahead and draw a profile view, just get a detailed assessment of the data. So here we have a 0.1 slice or a 10 centimeter slice. We'll go ahead and just select this here, pull over, and we can see that we have this very detailed thin line. If I go and make the points a little bit bigger so we can see this detailed, very detailed line. I'll come in here with a good measurement tool and get a good solid measurement of the X4 wall on a powerline scan. So we're still looking at about 0.3. So about 0.3 centimeters is the thickness of the point cloud that we are seeing from this overall scan. So we're getting a really good result with this data that we just collected of this distribution line. If we want to see a side angle, so we have our distribution line, we have our trajectory line. We actually have two distribution lines, so that's why the system was popping up saying, oh, there's a bifurcation, there's a crossing line that it's coming up on. Do you want to keep going straight or do you want to go right? Because we didn't input in a KML file, it is going to notify the pilot that those bifurcations are there, allowing us to adjust that. But in this case, we will go ahead and now highlight, if we want to look at some trees. I'm not sure how these trees are going to look, but we can go ahead and look at them. So from off on the distance, not so bad. So what I'm going to do now is go ahead and open up the other transmission line that we did. So we'll go back in here, browse, pull up the transmission line. Here, we'll go ahead, open up LiGeo again. And again, we have that same kind of result. We had two extra lines that were really unnecessary. But here we see the lines as themselves. We have it labeled as display by file. Change this to display by height. And now we can see the detail of this one that was followed directly by the side line. So we can see this trajectory here is the sideline following, and the one above is actually the overhead line. So in this one single flight, this is what I was indicating, that you can go ahead and do an above line following flight and also a sideline following flight. In the cases of large span conductors and wide gaps between the two of them, it is always, the system will autonomously lock onto the outside guide wire. And at the end of the tower line path, it will automatically cross over and safely fly back on the other side, making sure that it gets all of the data as it should. From here, I will go ahead and open up the H600 data. This was also captured, this was actually captured earlier today, or yesterday, yeah. So here we have the H600 data in all its clarity. We have our RGB loading in. My computer's just a little bit slow, so the rendering is just a little bit not the best. If we were to reopen this in LiDAR 360, we'd have a little bit better of a visualization of the rendering. But here actually, so we can see really detail, really clean. If I go ahead and draw a buffer across here, we'll do that same buffer, 0.1. Make sure to draw it across all lines. And with this, what we'll do is change the display to by file or by return. Actually, I'm just going to change it to intensity. This way we can have a really detailed view. So here we can see a bunch of corn crops just at that 0.1, so 10 centimeter slice. If we zoom in here on the data, we can see that the data is, as stated, uniformly set up. If we go ahead and cut a little slice here, we can still see that the data is around 0.3 centimeters collectively in between each of the lines. So this would be our strong result from the H600. If we wanted to take one little look here at the trees just to get a good vegetation measurement and view. So here we have very detailed results of the view of the trees. So the H600 is, again, as mentioned, extremely good for penetration, for vegetation. These crop fields that we're seeing out here just look like a hot mess, but if you actually look at them in detail, we have very good vegetation penetration. There's easy defined lines. So yeah, so H600, very solid product. It gets that survey grade measurements that are needed. And then we can check to see if the processing has finished here. So it's still a little bit of time processing there. So I think at that point, we will go ahead and I'll bring Louise back on the stage and continue forth.
Okay, from the X4's intelligent live following function and to our H600's efficient and high precision data collection to our upgraded handheld kit's flexible data capture. When combined with our LiPolar and our LiDAR 360 software, the LiAir series has proven itself as a powerful, field-tested solution for power, forestry and beyond. So Cody, thank you again for your in-depth demonstration, and we will take like 5 minutes break, and feel free to grab a drink, stretch a bit, and drop any questions in the comments. Our support team will be responding in real time, and we will be back shortly with our next product, LiGrip handheld LiDAR system. Thank you.
Thank you so much, Louise.
See you later.
As well as GIS mapping, are among the most advanced and reliable in the market. We provide complete turnkey solutions for a wide range of industries. LiDAR 360, our point cloud post-processing software, is used by customers in over 137 countries and regions worldwide. We generate inspection reports for power lines and create digital twin representations of real world, those to generate reliable information for infrastructure lifecycle planning. This is what makes our LiAir and terrestrial series systems very powerful tools. Our LiAir LiDAR system can be used to inspect all potential safety hazards in a customer's power system and aid in the preservation of the sustainable development of ecological forests. This safe and efficient automated inspection solution can also be utilized in diverse complex geographic environments. The LiBackpack LiDAR system can create a high-precision point cloud to help build smarter cities. The in-vehicle LiMobile LiDAR system overlays high-resolution maps onto urban roads. And our handheld LiGrip LiDAR system, a compact yet powerful tool, can adapt to complex construction scenes. Our efficient turnkey monitoring solution is also suitable for disaster investigation and emergency response, allowing early warning and scientific assessment of outdoor operations and disaster situations. This is who we are, GreenValley International, the explorer of the digital earth, striving to make cities smarter, roads safer, and ecologically more sustainable, all while contributing to the overall health and well-being of our planet. advancement of civilization. We explore
Complex environments got you troubled? Looking for a device that excels in data collection in any situation? Still troubled by data collection in areas with few or no features? Worry not, the LiGrip O2 Lite is here. Any scenario? No problem. It easily handles data collection across all fields. We've pioneered the MLF SLAM positioning and mapping algorithm. This algorithm allows easy adaptation to various scenarios, breaking through the limitations of conventional laser SLAM devices and allowing for stress-free data collection across all scenarios. Equipped with dual 12-megapixel cameras, microsecond precision time synchronization, perfectly presenting images. Dual V-SLAM cameras. Integrating V-SLAM technology with SLAM algorithms offer exceptional adaptability to environments. Despite its compact size, it packs a powerful punch, delivering outstanding 3D point cloud results. With absolute accuracy up to 3 centimeters, it meets the requirements for 1 to 500 topographic maps. The point cloud is highly precise, and the coloring accurately restores the real scene, facilitating efficient surveying and mapping. The O2 Lite supports a front pack and features a 2.5-meter telescopic pole for added reach, along with a dual battery backpack providing 4 hours of continuous operation. With multiple acquisition modes adapting to various scenarios, it boosts data collection efficiency. When collecting RTK data, equipped with a telescopic pole, it can precisely obtain high-accuracy coordinates at any position. Combining RTK plus SLAM technologies, there is no need to worry even in non-GNSS environments. Within 1 minute, the device can maintain absolute accuracy better than 5.
Only non-stop innovation can we redefine high-performance data collection. The brand new H600 airborne LiDAR system brings a revolutionary experience. The H600 is highly an integrated unit, with the laser, inertial navigation, camera, and centralized storage module combined into one, making it more agile and efficient.
Do a little bit.
The entire device weighs only 1.3 kilograms. It can easily be adapted to most multi-rotor drones. When paired with the DJI M300, M350, there is no need to disassemble or install the mounting structure, and the device can be installed in just 1 second. The H600 supports single antenna and antenna-free solutions. It is easy to operate when paired with DJI aircrafts and can also be adapted to use with many other brands and models of drones. With a high-precision, self-developed inertial navigation system, the elevation accuracy can achieve better than 5 centimeters.
Welcome back, everyone. From the skies, we now move to the ground, meet the LiGrip handheld scanning system. The lightweight SLAM-based scanner is designed for indoor mapping, tunnels, open areas, and other complex environments. So with the motto "Measure the world with precision beyond limits," LiGrip is engineered to handle environments where traditional mapping tools fall short. To take us through the details, let's bring back Cody. Cody. Welcome, Cody.
Thank you so much. Happy to be back. Hello, everybody. The pointer.
Okay. Here you are.
Thank you so much. Okay, yes, thank you again for that amazing demo with the LiAir X products and our detailed analysis of the data. We'll go ahead now and walk through the LiGrip O2 Lite, which is another one of our brand new releases this year. Measuring the world with precision without boundaries. So what is laser SLAM? It's a big question in the market. Most people are unaware of it. The people who are aware of it are still trying to wrap their heads around it. So we can just briefly describe what it is. So laser SLAM stands for simultaneous localization and mapping. It is computer vision for a robot or a device with a rotating or non-rotating LiDAR that scans the outline of its surroundings as it walks, with constantly compares the snapshots of the two scans before and after to estimate how much it's moved and where it is now, and gradually draws a map of the environment. The whole process is like a blind explorer drawing while touching, walking, and trying to figure out where they are on the map. As this wonderful scene from Interstellar says, that we are beginning to map walking through this tunnel. And then on the right-hand side, we can see something that was produced by our trusted partners, Candrone. This is actually our LiGrip H600, utilizing the H20 infrared, showing exactly what the laser sensor looks like while it is scanning. As we can see, because it's spinning, we have a 360 degree plus a 360 degree, which gives a full detailed grab of the environment. As it's walking, it's able to constantly look back at its objects. It says 1, 2, 3, 4, 5, and then it marks that as 1, 2, 3, 4, 5. And as it's walking, it's constantly looking back and saying, there's 1, there's 2, there's 3, I'm here. That's how it's able to know where it's at, collectively build this map and maintain this level. Where a traditional INS system like that of our LiAir X4 uses an inbuilt INS and IMU to measure offsets in the X, Y, and Z, pitch, roll, and yaw, along with GPS satellites to know where it is at in a geospatial realm. So compared with the advantages of traditional measuring equipment, something like a rangefinder or a total station, they're cheap or cheaper depending on the model and the make. Personnel costs is measuring 1 to 2 people, 2 people measures. Applicable scene, indoor, real estate, indoor and outdoor terrain monitoring. In terms of the measurement efficiency, you have 3 to 4 houses a day, 1 to 2 houses per day. Difficulty of use, easy, it's harder, it's moderate, millimeter level. Something down here like laser SLAM, the price is moderately expensive depending on what it is. Something like the LiGrip O2 Lite is very cost effective. Measured by one person in any scenario, can measure up to 10 houses easily in a day, and the difficulty of use is moderate to easy depending on the system, measures at centimeter level, and has automatic logging of large areas. 3D laser SLAM technology is the latest generation of measurement technology. 10 times more efficient compared to conventional measurement methods, simple acquisition, one-person operation, ultra-high measurement frequency and coverage, centimeter level high accuracy, support for GNSS jobs, adapts to all scenarios, indoor, outdoor, airports, woodlands, water, mine, deserts, etc. 3D results, a one-stop output of point clouds, 3D mesh, 3D Gaussian, panoramic images, all in one to get a very detailed, realistic scene of the environment. Introducing our LiGrip software and hardware solutions, starting with the hardware. So LiGrip's one-stop solution, easily device control and configuration with inside of our GreenValley app, which is Android and iOS capable. Alongside with LiDAR 360 MLS BP module, it has high precision post-processing software and industry applications and online releases such as our LiShare platform. The LiGrip product development history all started around December of 2021 with our LiGrip V100. The first generation handheld system by GVI. Around August or June of 2022, we released LiGrip H120, which was the first handheld to use the Hesai laser sensor. In 2023, we released our LiGrip H600 first generation, which had the Hesai XT32 M2X with a range of 300 meters, a Leica approved sensor lens, supports RTK, and also had multi-platform mounting kits, such as a mobile kit and a UAV kit, along with our backpack kit. In 2024, we released our LiGrip O2 Lite, the first handheld product with GNSS built on it. In 2024, at the end of the year, we released our LiGrip H600 second generation. Same sensor, utilizing the X4 lens for higher def 8K resolution camera, and it supports also multi-platform, high precision, and high precision collection, along with 3D Gaussian splatting. Now we have released in early this year, April, our LiGrip O2 Lite. a very lightweight handheld laser scanner for all scenarios, which includes VSLAM. Now on to the LiGrip O2 Lite. Again, it's lightweight, full scene handheld laser scanner. Highlights featureless data collection. So MLF SLAM, featureless, fearless of feature-free environments, high speed or moving objects, and full scene data collection. No need for features, capable of capturing data in open scenes. So open parks, open areas like what we're standing at now, it has no issues when it comes to the processing, where previous gen may have had issues in open areas. Some of the highlights, again, are the precision data and outstanding performance, surveying grade accuracy with high precision and stability. Point cloud is horizontally and vertically aligned. On the left-hand side, we can see an absolute accuracy of 3 centimeters or less, a relative accuracy of 2 centimeters, a repeat accuracy of 2 centimeters from A to B, and buildings are vertical, basements are horizontal. The above values are measured in GreenValley's precision field. Deviations may occur in some scenarios. The accuracy verification is repeated with 2 scans with GNSS, and the GNSS disconnection does not exceed 100 meters. Highlighting that of a multi-floor building, we can see that this is a 7-story building with easily and accurate data. This is a parking garage of 7 floors. Again, highlighting that each of the lines, each of the floors are lined up perfectly as they should be, with a distance gap between them of around 20 centimeters. Same situation, we can see from top to bottom, we have the same variations in elevation, 20 meters, and then we can also see that the distance of 25 meters across allows it to stay capable of multi-floor SLAM mapping, and it's a core metric for evaluating the mapping performance of a handheld device. In this situation, we can see that we have a cross profile view, which indicates that between the different time frames of the scan, we're seeing a sub-centimeter measurement in the X and about centimeter or centimeter and a half measurement in the Y. Again, repeatable accuracy is the most critical indicator reflecting the stability of SLAM precision, which indicates that of SLAM drift. The system itself has dual high definition panoramic and dual vision cameras. 2 times 1.3 megapixel V-SLAM cameras to allow the device to add SLAM using cameras instead of just the LiDAR itself, adding to that level of correcting any form of SLAM drift. Dual vision brakes, boundaries, no limits, and 2 times 2 12 megapixel panoramic cameras, which are meshed together to create one single 360-degree image inside of LiDAR 360 MLS, or when you take that image to use it in a third-party software. The panoramic effect is outstanding with seamless stitching and no issues of color or light intensity variation. So in this image, we can see that we have 2 12 megapixel panoramic cameras meshed together in one directly within the software without any visible stitching or intensity and variation that may be caused by other third-party products. Some of the other key highlights is the one-time data collection, a multi-dimensional output. So on the left, we have the point cloud, we have a panoramic image, and on the right, we have the 3D Gaussian splatted with a 3D mesh model. The cost reduction and efficiency has been enhanced. This data was actually captured by one of our trusted clients in Riga, GeoPro. This is a graffiti wall that is very famous there in Riga, and they were able to go out and capture the data and produce this 3D Gaussian splatted model. As you can see, the detail is so clear that it is indistinguishable between a photo and or a 3D model. The detail is very crisp, very clean. Why, thank you. Yes, it is scorching hot out here. Woo! Okay. Continuing on. Highlight 5, real-time processing and colorization, exportable for use. Real-time true color point cloud mapping, ready for immediate export. Supports multi-scenario applications such as earthwork calculation, individual tree segmentation, and topographic mapping. The real-time point cloud thickness is around 3 centimeters, and the real-time point cloud accuracy is around 5 centimeters. Again, this is generated in real time. So as soon as the scan is done, you can pull this file off and operate and use it in the field to do any type of adjustments or measurements or calculations, making sure that you don't take the time to go to a location, miss what you needed to collect, only to find out that occurred back at the office after you've driven back 5 hours from this location. Multi-form data collection. So it supports various forms of data collection, such as our handheld, which is based that way, a backpack kit, a front pack kit, and a telescopic pole, allowing for flexible adaptation to diverse customer collection scenarios. Our LiGrip O2 Lite is RTK SLAM acquisition mode, so self-developed RTK SLAM technology with telescopic rods. It can realize global high-precision RTK data acquisition with an accuracy of plus or minus 5 centimeters within 1 minute without GNSS. The RTK SLAM deep fusion technology and also that 1 minute accuracy within the 1 minute accuracy of 5 centimeters without GNSS is what is allowing this device to be industry leading. 7 core highlights of the LiGrip O2 Lite. The dual HD panoramic plus dual vision cameras, so 2 12 megapixel panoramic cameras to restore the real world, 2 1.3 megapixel visual SLAM cameras makes mapping more stable, real-time calculation and colorization, so real-time true color rendering, export available right away, and an absolute accuracy of 5 centimeters within minutes of processing or of collecting. One-time acquisition of multi-dimensional output, so multi-source integrated acquisition, reduces costs and increase efficiency. Point cloud, panoramic, 3D, GS, mesh, all in one place, all with one touch of a button. Multi-form saving, effort, and time. The backpack dual battery supply, battery life gives it up to 4 hours. The telescopic rod can measure data of objects over 5 meters, and the labor-saving kit can adjust the height and angle at will. Our RTK SLAM acquisition mode allows for RTK data collection possible in areas without GNSS. Maintain an absolute accuracy of 5 centimeters within 1 minute. No fear of low features, so our multi-sensor fusion positioning allows for breakthrough the limitations of traditional SLAM relying on features. That allows us to do scans in open areas where there is not objects for that SLAM to constantly look back at. That comes from our self-developed algorithms. So adding to high precision and high efficiency. Accurate data, excellent results. So absolute accuracy of 3 centimeters, a repeatability of 2 centimeters, relative accuracy of 2 centimeters, and a horizontal and vertical of 2 centimeters. Moving on to our LiGrip H600 second gen, the long-ranging multi-platform mobile LiDAR system. The LiGrip H600 has an ultra-long range with ultra-high point frequency. The new XT32M laser has a maximum range of up to 300 meters and a point frequency of up to 640,000 points per second on that first return. Only higher point frequencies and longer ranges can be mounted on mobile platforms or multiple platforms such as a UAV. Our LiGrip H600 has a variety of kits, as mentioned before. You can carry your kit on your back and keep your hands free. A car kit with large area measurement tool, airborne kit integrated above and below the ground, and measurements based on the system. The H600 has an ultra-long battery life, a 5800 milliamp large battery with battery life up to 3 hours each, 2 batteries together for a full day of usage. The H600 is also ultra lightweight. It supports detachable cameras with a detachable base plate if the cameras are not needed. So the handheld with the base and camera is about 1.5 kilograms. The handheld by itself, 1.26, handheld plus camera, 1.5, and handheld plus base is just 1.3 kilograms. So it's lightweight and efficient. The LiGrip H600 with the new X4 camera performs better indoors, in underground garages, and in low light environments, leading to ultra clear image quality. The camera does not need to be powered by batteries and is equipped with a metal heat dissipation structure, allowing the camera to quickly dissipate heat without fear of high temperature operation, meaning that you can extend your collections outside or in hot environments without fear of overheating. Our LiGrip H600 supports PPK plus RTK. So RTK SLAM, PPK SLAM, and just SLAM. It has RTK mods, allows for satellite signal from GPS, BDS, GLONASS, and others, supports RTK accuracy of 1 centimeter, plus 1 per minute. RTK protocol is the typical N-trip protocol. The weight of the system is around 190 grams. GNSS raw data format is stored as a log file. The RTK data format is stored as an RTK file, and our compatibility is with our H300 and H120. This is another example of Gaussian splatting done with inside of LiDAR 360 MLS, but from the LiGrip H300 of a substation. So this device can also be used for power line inspections, power facility inspections, leading to very detailed and accurate representations of industry standards. 6 core highlights: the XT32 M2X laser, 32 lines, 300 meter range with 640,000 points per second, ultra clear image quality with an 8K resolution detachable panoramic camera, ultra long battery life. The battery life can last for up to 3 hours. Ultra lightweight. The lightest weight is 1.26 kilograms. As mentioned, RTK, PPK, SLAM, and multi-platform handheld carrying vehicle mounted and airborne. LiGrip series highlights: it's a game changer. One-stop solution from our GreenValley app all the way through to LiShare or LiDAR 360, utilizing GreenValley's new AI platform. Leading in high accuracy, adapts to all scenarios, true panoramic view. All-in-one, self-developed PPK algorithm, ultra-high solution efficiency, one-touch operation, iOS and Android capable, multiple kits supported, and results are generated with one click. Now, LiGrip software hardware solutions. We'll go ahead and do the live demonstration of our LiGrip O2 Lite.
Yes, let's go, Cody. Director, please switch the camera to our demo area. We will show the LiGrip O2 Lite demonstrations. Okay, unboxing our O2 Lite, Cody.
Yep. All right. So we have the entire LiGrip family here in terms of the LiGrip O2 Lite. What I'll do is I'll start with the system itself, and then I'll walk through the kits that we have available for the system. We have our very small, ultra lightweight box carrying for the device itself. Everything easily and well maintained and organized inside of the box. We have our base plate. We have our battery. As we can see, there's this push button screw and a screw on the bottom with 2 pins that allow for an easy attachment with just a couple twists of the screw. Our device is now attached fully and ready to be assembled incomplete. We have our system, which we can pull out, and it has a safety protector just to ensure that the cameras and the sensor don't get damaged during transport or also removing the device itself. The system has a very easy latch removable system with the button operation to make it so it's super simple. And now our device is set up and ready to go. We have our LiGrip O2 Lite. Inside the box, we also have the charger and a provided USB cable for storage to pull on and off the data. And yeah, I think that that pretty much covers the majority of it. And we'll walk through.
Yeah, we use this interface to transmit the data, or
exactly. So the
can
provided
use the USB drive and
exactly. So we can either use a solid USB-C cable for direct transport of the data or transferring of the data, or also a USB 3, USB-C provided thumb drive.
So you want to perform the operation or the data collection?
Yeah, so I'll actually do the data collection on the backpack.
Oh, great.
So what I'm going to do is I'm going to disassemble this and go ahead and set it up on the backpack itself.
Yes. I think this is also the newest product.
Exactly. Yeah. This product is brand new. We just officially released it, I think, a couple weeks ago. So the system itself, I'll have you hold this for me for a second.
Okay.
Just one click. We now have the backpack ready to go. We'll go ahead and tighten the thumb screw in the back, and that is the full assembly of the backpack. Now we'll go ahead and put the head on the device. Same slide-on situation with one push. We'll make sure that everything is good to go and tight.
Locked.
So the other key factor about this that I mentioned in the presentation is the backpack actually allows for dual battery use. So it will use both batteries at the same time, extending what would be a 2-hour battery life to a 4-hour battery life.
Oh, it works at the same time?
Exactly. So at the same time, it decides to draw the power the way that it should to make sure that it easily and adapts to both batteries. Now
so
we have our
two
system.
Batteries, we can work for 4 hours?
4 hours with the system.
Okay.
And so as we can see, super lightweight, similar design in terms of the backpack wearing kit to our H300, which is extremely comfortable with cushioning to allow for the user to wear for that 4 hours or more. We have these push buttons that allow for the device to easily be stored as needed. Just push forward, and now we have the device easily store and or set up like this. So the first thing that I'm going to do the collection of this device is I'm going to power it on. So I'll go ahead and turn this around so that we can see the back interface. As mentioned before, this device is RTK PPK SLAM. So we have our RTK antenna, we have the LiVox mid 360 sensor on it, our two 12 megapixel cameras, and our two visual SLAM cameras. 2-button operation in the back. We have a power button that allows for a manual powering on of the device. And then we also have a start and stop button. So the device can be operated from our GreenValley app.
Yes.
But say your phone dies or whatever it may be, you're in the field, you still need to collect data, but you don't have a handheld device, you can always power it on and operate the device manually from the 2-button operation in the back. So as of
get the GCP points with the button?
Yeah, so the device allows to collect GCP points when using the handheld device or the RTK just by one single touch operation.
Okay.
Both from the app and also from the device itself. So full manual operation without the need of a remote.
Now the device really supports the vSLAM?
It does, yes. Yeah. So just recently we released the full functionality of our vSLAM, which users can see the vSLAM processing inside of LiDAR 360 MLS-BP, which is provided with the purchase.
Without the firmware upgrade or?
Without a firmware update.
If customer has bought the device, they can also use the vSLAM with the software upgrade.
Exactly. So yeah, so no additional need for any firmware upgrade. It's purely a software-based situation. So
yeah, great.
So the first thing I'm going to do is walk over here and show our GreenValley app.
Show our amp.
So we have the GreenValley app, our main interface, which is the main page. We can see our different product lines here. What I'm going to do is go ahead and click in the LiGrip. The very first thing that you'll see pop up is the device model. So we have several different types of models that have been released. In this case, we have our LiGrip O2 Lite, which is automatically chosen, and it has an image of the O2 Lite. So I'll go ahead and hit OK. In this case, it's asking, do we want to use RTK? We're going to go ahead and...
What's the difference if we choose?
If we choose no, then it's just going to operate with PPK or SLAM.
I mean the collection method. So we provide two methods of the collection?
Exactly. So RTK would be real-time kinematic, which means that you can connect to a local CORS N-chip provider, allowing you to operate without a base station. So then you can have RTK SLAM or non-RTK SLAM, PPK. So you would need a base station, and that would be if you want PPK. The device is capable of collecting just pure SLAM, indoor, no GNSS, no base station.
Yeah. No SIM card?
Yeah, no SIM card, yeah. So previous models, we did have a SIM card. This device actually utilizes the cell phone to draw data.
Yes.
So it grabs data directly from the cell phone or from the device. So in this case, I will choose RTK. So in these steps, quite simple. The very first thing that we do is set up the Wi-Fi. So the very first thing that it's going to do is look for the Wi-Fi. I have already connected to this device, so it says LiGrip O2 Lite. So I'll go ahead and come back into the GreenValley app. The next step is that we're going to do a hotspot configuration. So here I will turn on the hotspot of my device. The reason why we went with the hotspot is to allow users to continue using their phone. So if you need to use your phone at the same time, you can use your phone and allow for hotspot to be in the background, keeping the device activated and continued efforts. So I will go ahead and hit hotspot configuration. The device has now been connected to my phone, and I will go connect device. But first and foremost, we can see the device name, which is based on the serial number of the device. We can see the IP address from the device communication and the hotspot name from my phone. It says device connected, connect device. The very first thing that pops up is a power on self-test. Here we can see indicator lights and the situation of the device. So we can see that the LiDAR status is normal, the camera status is normal, GNSS is normal, and it's actually seen 28 satellites already, and the IMU, remaining storage, and battery level all are optimal, indicating 6 green lights. Here is the main interface for the device management. We can see the device's serial number, the battery level, the device storage at this point is 25% left, or only 25% has been used. We have our project management page, which highlights exactly where the data is at. We have our activation status, so this device has been activated. We also have our firmware information, so indicating the latest firmware, which if it is not the latest firmware, you can search for it by doing a firmware upgrade over the air. And then equipment diagnosis is that same thing, highlighting the device's status of all the self-check that it runs through when you power it on. So in this case, it's connected. I'm gonna go ahead and hit start operation.
Okay, Cody, back to the collection. If I have configured the parameters like hotspots, and next time I want to connect my device, so should I configure all the parameters again?
No, so since you have already shared your hotspot with the device,
yes,
as soon as you turn on the device, you can actually just turn on your hotspot and it's gonna locate it, including anything
automatically?
Automatically, yep.
Okay. For 5 seconds, 1 minute, like
how long it will take?
How long it will take to collect the device?
It should be automatically, as long as it's within range. So 5-10 seconds, depending on how long it's going to take from your phone.
Okay, got you.
So we have our collection management. We have the same indicator light showing here. And if we want to, we can pull it down and see a mission working status. So we can see the project previous name, the mission name, the walking distance, the equipment form that was used in the previous project, and the capture mode, along with the RTK current working status. So right now it's at single point solution. We have a horizontal and vertical error of 1.8 meters, 2.5 meters in a single point. So what I'm going to go ahead and do is pull up the settings menu, which here we can see we have base station for virtual base stations, RTK link, camera frame settings, high, low, medium, depending on what you're trying to collect. If you're doing 3D Gaussian splatting or not, you can save or enhance the quality of the images.
Yes, yes.
Hard drive formatting, in case there's issue with the hard drive, you can reformat it, and then allowing for automatic shutdown of the device. So in this case, I'm going to go into the RTK link, and I already have a stored RTK address set up. So we have the domain name from the RTK address, the port, the mounting point, and then also username and password. It is already stored within the system, so if you've put in this information, it will automatically save it and allow you to easily just touch it the next time, quickly connect and get to your scanning. From here, I'm going to go ahead and hit commit. It's saying RTK configuration. If it's successful, it shoots a message saying RTK configuration successful, fixed solution. So what we'll do is we'll come back into the main interface, and we see that we're seeing an astonishing 52 satellites with a fixed GNSS, which means the device is ready to go.
Is enough?
Plenty, yes. Yeah. Yes, plenty. So a few other key functions of this interface is a lock button, which makes it so where the screen will stay locked, so that if you were to get a phone call or something, it'll keep that and you can adjust it and take that phone call. We have our start collection button, which is a play button. We have our GCP collection button. And then on the bottom, we have everything for the real-time visualization. So we have a follow feature, which allows you to translate or rotate the real-time point cloud. We have a slice, which allows you to view elevational differences. We have a measurement tool, which allows you to select 3 different points and then 3 other points and physically measure the real-time point cloud. It's a very beneficial thing because you can take that measurement and also double check it in the post-processed data, and you'll see that the same visualization occurs. We have our color bar, which allows you to visualize the data in a difference of displays. We have a zoom function, a size function, and a reset function. So in this case, what I'm going to do is go ahead and hit play. I'm going to choose webinar demo, which is a name that I already made earlier. But we have, so in the settings, it sets a project name and then mission name. So a project name means, say this is day 1 and we have 10 scans that we're going to do in one day.
Got you.
So I'm going to call day 1 the project, and then each mission, I'm going to say scan 1, scan 2, scan 3, scan 4. Or first floor, second floor, third floor, fifth floor, or building 1, building 2, building 3. That way we know exactly when we go back to process which one is which.
Yes.
In this case situation, we're just going to leave the mission name, the base default, which is the date, time, minutes, and seconds every time.
Let's show this to camera.
So the scene that we're going to...
Okay, we can walk a little bit to
into the shade.
Into the shade.
That makes sense. Okay, so the scene that we're going to collect today is outdoor, but we have a difference in scenes that you can choose. We have outdoor, indoor, indoor plus outdoor, tunnel, and open area.
Oh, even include tunnel?
It even includes tunnel, yes. Yes, so the tunnel would be best functionality for the visual SLAM and for areas where the GNSS denied environments. We can use the tunnel mode to optimize the algorithms used for the processing for the real time. Open area would be, again, an open field. No objects, no nothing. The device automatically will take it as, okay, there's nothing for me to really grab. Let's use GVI's handy new algorithms for the MLF SLAM, producing these results that we're hoping for. In this case, I'm just going to choose outdoor. It's a simple setting. Operator name, I'm just going to say GVI. This is metadata that's saved, so you know that, you know, John over there did this scan. If he messed up, we can go after John. The weather is ultra sunny and extremely hot today, so I'm just going to say sunny. And if I could, I would put the temperature at 1,000 something, but I'm just going to say 100 Celsius, which is abnormal, not real. And the equipment form, we have handheld and pole. So earlier we mentioned that there is a RTK pole. That RTK pole allows for you to collect GCP points and RTK points, and adjusting that in the app is critical to make sure that it's utilizing that. Here we have the real-time point cloud. This real-time point cloud is a 2-factor function. One factor is that it will produce a real-time point cloud and have that point cloud generated right away. So it does take a little bit more time because it's generating this point cloud. If you're in a rush and you don't need that real-time point cloud, you can set it as closed and it will automatically close it. The other, go ahead.
Yes, I want to make sure if the real-time point cloud is colorized.
It is colorized, yes.
Really?
The real-time point cloud that's generated is colorized, and also if you have RTK, it's got RTK points as well.
Oh, cute function.
So the other functionality of the open real-time point cloud is if you're going to do multiple scans and you want to be able to register those scans automatically. So you can do continuous breakpoint continuation function.
Continuous.
Exactly. So say you have 15 floors you need to scan, and you can only theoretically scan 5 at a time, or, you know, make it up 5 flights of stairs at a time. You can go up 5 flights of stairs in that collection as long as you start the next collection from the same place with the same angle. Even if it's 5 days later, you can do the breakpoint continuous.
5 days later?
Exactly, yes, because it saves the angle of the location and you just use the same project name. So then you can do your breakpoint continuation function, allowing you to do these continuous scans.
So no need to remember the specific point. I should start here again.
It's best if you do, yes. And so one of the other key features that I'll show is this amazing choose picture. So what we can do is we can go ahead and take a picture of the device itself, not of Louise, but we'll go ahead and take a picture of the location. That way we know where the last person, John, who messed up our scan that one day, we'll make sure that he knows the position for the next time. So now I'm going to go ahead and hit start collection. It gives us the start task check, so we can make sure that everything is good to go. We have green lights across the board, and a few factors that you see now is the scene, the equipment form, the video capture mode, and the camera frame rate. So we can see that the camera frame rate is at 3 Hertz, which is the medium setting, and then we can go ahead and hit start collection.
If I need build a 3DGs module, I should choose high?
You should choose high, yes. Which at this point is a 5 Hertz.
Okay.
And so what we can see, nothing has started other than the fact that up here it says collection preparation. Right now we're at 10 seconds. This collection preparation is key, just like the LiAir X4. It is the initialization phase. This part is building a base map for it to constantly look back on. So the SLAM will always constantly look back in this case. So at about 30 seconds or so, 25 to 30 seconds, it will say collection beginning. That means we are able to pick up the device and start to walk with it. If we come out of here and we zoom, we can now see that we have a real-time point cloud that has been generated based on the initial view of the point cloud. I can rotate it. We can see that we have these buildings that we're looking at. We have some buildings over here, which is us in the point cloud as well. So then we can move it around. And as mentioned, we have an elevation slicing. So if we want to see just the ground floor or just the ground and nothing else, we can elevationally slice this to see just ground. If we want to see just the tops of the buildings, we can take the ground away. Now we see just the top of the building. All of this is easy function factors for us when we're doing real-time point cloud analysis.
Yes.
So from here, what I'll do is I'll go and put the backpack on.
Okay. Did you finish the installation?
I did.
Which is the most important.
I did. I made sure everything was good to go. Devices set up, good to go. So what I'll do is I'll go ahead and pick up the backpack. It's always best to pick it up and keep it in a stable direction and turn yourself into the backpack, making it very easy. I'll go ahead, put this on this side. If you want to, you can strap it in, but unfortunately I'm a big guy, so I'll just leave this unstrapped for now.
I can adjust it.
We can adjust it, but it's okay.
It's okay?
Yeah, it's okay.
It's easy to adjustment.
There we go. Big boy
There
approved.
you go.
Big boy approved. Okay, this one, same thing. Big chest approved. Okay. All right, so now, good to go. Now we have our device.
Very handsome.
Thank you very much. So now we have our data, and what I'm going to do is go ahead and walk the parameters. In this case, no need for a figure 8.
Really?
From my understanding.
Yeah.
In the past, we always suggested the figure 8, but because we're using RTK,
No need for figure 8.
no need for that.
Yes.
So the speed that you should be walking at is your basic speed, 1 meter per second.
Exactly.
You can technically run, but there's no need.
I think you can run. This is our new key function.
The running function.
Yes, the running function.
It'll be added, and it's called running.
Running.
The running man.
Now running. 3, 2, 1, running.
Run. Okay. So in real world, obviously, I'm going to walk much further than that. The scan's going to last much longer than that.
Okay.
This total scan, as of now, 3 minutes. So a good scan time is usually 15 to 25 minutes. Many people will push it to the limit, obviously, because they don't want to scan for too long. Yes. I mean, they want to scan for too long. So they want to get the most out of their scan. So now that the device is done, we've done our collection. We're just going to come over here and get back with the camera so that they can see the user interface again. Let me get my fingerprints cleaned up.
It's too hot here.
Okay, so now what we have is this whole field. We can see this beautiful real-time point cloud. And what I'm going to do is go ahead and just make a quick measurement. So what we can do is rotate this so I look up at the top. We got these basic tents. These are very common tents people use when it's extremely hot outside. So I'll go ahead and hit measure. Zoom in. What I'm going to do is choose set area. I'm going to select 3 points. Terrible fingers. So I'm going to put confirm area, and now I'm going to set the area number 2. 1, 2, 3. Confirm area, and then I'm going to start the measuring distance. What this just did is measure the distance between those 2 points. And as we can see, that distance is about 3 meters, which is very, very accurate for this.
Yes.
So obviously not down to that centimeter, because we need better tools to be able to do that, to verify that in real time. But in this case, we were able to show and highlight we have our beautiful real-time point cloud with our real-time visualization of the measurements, both clearance distance, horizontal distance, and vertical distance. At this point, what I'm going to do, actually just for the show, I will go ahead and drop a GCP point. When you click GCP, it automatically preloads a default LiGrip 0. If I go and drop 10 GCPs, it'll be LiGrip 1, LiGrip 2, LiGrip 3, LiGrip 4.
And
so
our software can read the file.
Exactly. So our software automatically reads the file and allows you to do adjustments based on real known GCPs. So a traditional scan would be that you would take those GCPs over known benchmarks or over known GCPs. You bring in that reference file. That's how you can do accuracy checks based on very accurate data.
And our LiDAR 360 also can export the accuracy report.
Exactly. An accuracy check from LiDAR 360 and from MLS as well.
Yes, MLS as well.
And 2, if you have the control points, the circular control points, LiDAR 360 can automatically detect those control points for doing control point reports and adjustments. So I will go ahead and hit the stop sign. What it says is note stop collection. Okay. we're going to get a progress bar pop up that starts to tell you how long it is for this progress. Because I chose to do a real-time point cloud, we have 2 bars. If I did not choose to do a real-time point cloud, we'd have a single bar that just says raw data is being saved. Because I chose 2, we have a real-time result generation in progress. So we can see the time it takes to save raw data and also the time it takes for the app and the device to produce this real-time point cloud that has been colorized and also with RTK points.
I think real-time point cloud data is very useful for initial check for the data if it can meet our requirements, and we can back to our office to process the data.
Exactly. So we always say that to get the best results, utilize LiDAR 360 MLS to verify that you have your best results. But in the field, you want to do a quick check to make sure that your points are roughly in the right spot. It is the best and easiest way to do it. Pull it off. It's in LAS format. You just pull that file off, load it into LiDAR 360, and you have yourself a good data set that you can visualize in the field in real time.
Yes, agree.
So as you can see, the data has been saved. One of the cool functions is that it will automatically still have this point cloud there. So I did that measurement during the scan while it's still collecting, but you can still visualize it after the fact. So you can visualize it, do the measurements. One of the slices that I was talking about earlier is if I was to pull the ground away, then we have just the buildings, very visual. If I want just the ground and pull those buildings away, now we have a very strong visual of the ground. So just some of those key functions that really do make a difference when you're in the field.
Yes. Cody, can you make a briefly introduction of our new front pack and the extension pole adapter?
Yes. So we have this new front pack kit. This system is designed to put the system in front of you. So it just goes across your body as
face
such.
to the camera.
Goes across your body as such. You put the device here. It sits on a extended rod, making it very easy for the user to operate and have the system here. So then you have a system completely hands-free with the cell phone or the iPad, tablet, whatever you're using to visualize your data, allowing the user to be free. Yes.
Thank guy, okay?
Big guy, not proof.
Okay, how about this?
So this is our RTK pole. This is an RTK adapter.
For so you mean our LiGrip O2 Lite can use as the RTK device?
Exactly. So our
receiver.
Our O2 Lite can be attached as an RTK device to capture RTK points at angles, measurements, get your RTK points, get up into crawl spaces. So an extension rod allows you to get up in crawl spaces. But another beautiful function about this RTK pole is for 3D Gaussian splatting.
Oh, really?
So say you have a situation where you have a sculpture that is much higher or taller than the user, but you want to get really detailed accuracy and images of the face of this sculpture. You can take the LiGrip and put it up there and allow the LiGrip to capture really, really good, high, crisp images that the user wouldn't be able to do. Just another verification of our 3D Gaussian splatting, trying to meet the best industry standards.
Very cute accessories. So I think that's okay. Are you angry?
No.
You're happy, right?
Yes.
Okay. I think this is a whole part of the LiGrip O2 Lite introduction for the demonstration. And let's back to the stage to show how we process the data and the application.
Perfect.
So please, director, please switch the camera to the stage.
Okay, now we are back on the stage, and I will go ahead and now open up LiDAR 360 MLS. Thank you very much, Louise. Okay, so now we have LiDAR 360 MLS version 8.2. The very first thing that I'm going to do is, same as I did with the LiAir, I'm going to walk through the steps of processing the LiGrip data, and then I'll pull up some LiGrip data that we have already collected here for visualization purposes. So when it comes to the LiGrip, the first thing that you're going to do is select New SLAM Project. This will automatically open up a project file. From here, I'll go into the LiGrip O2 Lite and highlight what it is when we have our raw data. So our raw data is generated as the date, time, in minutes, seconds, if we don't choose to set the project name, like I was saying about day 1, day 2. So in this case, it's just date, time, minutes, seconds. Here we have the similar project function set up in terms of the way that the device produces this point cloud. Produces this subfolders. So we have our base, we have the camera raw, we have GCPs if GCPs are collected at the time. We have the laser raw, which is the point cloud file. We have log, para, like parameter settings, real-time result, and rover result. The first thing that I'm going to do is save a project file. So this one is just going to be called the date and time of right now .mscan. I'm going to save it in this project folder. Here we have the main interface of LiDAR 360 MLS BP. From here we can see that we have nothing loaded. All that was loaded and created was the project folder where everything will be stored. So the first thing I'm going to do is click on the cloud with 3 points. I'm going to go in, I'm going to find the LiSlam file. The LiSlam file, if it is one project, like 1 day's worth of project with 10 different types of projects collected, you'll have one LiSlam file for that set of projects. When you select that, if you had multiple projects, you would see here the names that you gave. So first floor, second floor, fifth floor, building 1, building 2, all those would be saved here. So in this case, we have one project. I'm going to go ahead and select that project. What happens is it automatically pulls in the information and file related to this project. As of now, just the trajectory has loaded, as we can see here. What I'm going to do is right click on the highlighted project name and open up the project settings just to verify that everything came in correctly. Under raw data, we can see that the laser file is a .bag, which is a proprietary file from our systems. We have our camera file directory for the cameras, which is the built-in cameras. We have the DGNSS, which is the GNSS trajectory file. We have target coordinate system, general, IMU constraint, loop optimization, filter. So if we're going to do a high density mode at 2 millimeters, we can choose to do that. Just note, it takes a little bit more time for the high density because it does make a very dense point cloud. Can create extra points if needed. Classification, which allows for one-touch operation classification, and then also colorization. We do have auto set mask files for this system, so all you need to do is select auto and it will choose the best setting for that. We have 2 different types of mode, color by distance and color by time. Typically, we just state the default would be best at color by distance, but if users want to adjust or work with the color by time, this is also a possibility. Another thing that we have added is optimizing sky colored points. This function is designed to true color points that may be affected by blue sky, gray sky, making it more realistic, utilizing kind of like a closest points value to RGB, such as trees and the tops of buildings and things of that nature. So at this point, all of the settings are good to go. I'm going to hit apply to all. Over here, we have a secondary setting where we can see what we just selected in case we missed anything. And one of the things I want to highlight is the dynamic object removal. In the past, our system did not have the ability to automatically remove objects while in the walk. So that's one of the key things, is that during slam walks, you're going to have what is considered a ghost if there's anybody that's walking around, usually at human level. So adding a function that allows for dynamic object removal right off the bat means that once the data has processed, if there was 10 humans walking around, you're not going to have this ghosting effect that occurs in many of the third-party competitors' products. In terms of output, one of the things I didn't highlight is our carrier filter. So this is what is designed to remove myself from the process point cloud. So if I'm holding the device, it's going to make sure that I am and the device are not in the point cloud itself. We also have that max range distance, so being able to maximize the output of the system. Something like the O2 Lite, keeping at 70 meters is perfect, but something like the H600 with its 300 meter range, depending on what you're trying to scan, 300 meters might be too much. So then you can keep it down there at like 120, 150. But in certain situations, you may need the 300 meters. So selecting 300 meters as an output is optional for you to choose as a range filter. So in this case, I'm going to go ahead and apply to all, hit OK. And as we can see from top left to right, we make our system extremely easy to use. As we had mentioned, one-click operation. So we have our DGNSS process. We have the SLAM processing. If we had GCPs, we have a GCP optimize. We have built-in filtering, which is what I was talking about, the carrier filter, the distance filter, things of that nature, which also increases the processing time. Colorization also can be checked right away so that you can process everything as one, including creating your mesh model and also classify by deep learning. Our different modes, as mentioned earlier, we have different modes in the LiGrip user app. Tunnel mode, for instance, is something we highlighted. When coupling the tunnel mode with tunnel mode in LiDAR 360 MLS, this is when you're going to get the use of the VSLAM parameters. So as it shows here, we can see that it says VSLAM processing, designed to process VSLAM. Best use case in heavily GNSS denied environments, darker environments, these really tight spaces that VSLAM really kicks in and allows for a very strong processed result. As Louise had mentioned, we have a report generation function, which allows for an accuracy check and a GNSS report. Then at the end of the processing, we have this convert button. What this does is it converts the project to a 3D mapping project inside of LiDAR 360 MLS, giving you the full suite of post-processing steps. In this case, I'm going to go ahead and hit start. And so we can see that we have generated what is the processing of DGNSS, SLAM, GCP, register, filter, colorize, mesh, classify by deep learning. I will go ahead and open up another MLS to open up the projects that we have already processed to highlight some of the data. And for those users that were here or the viewers that were here before, this is our georeference result from that data set that we had captured after processing in LiGeoReference. But I'm going to go ahead and close this out to save up a little bandwidth on my computer. So I'll come in here and I'm going to choose New Mapping Project. This is LiDAR 360 MLS again, just to highlight. By clicking this allows me to input third-party data if needed. So I'm going to first add in the point cloud. From here, we'll go to LiGrip O2 Lite. We'll go to Test. And we have, let's just say, the 11. I'm going to load in these two LiData files. Open. Now I'm going to do trajectory. I'm going to load in the trajectory file. Now I'm going to load in the image list from the camera. Now we have all the parameters set to create this converted mapping project. So what we have here is our real-time colorized point cloud. We have our colorized visualization of the building. The points here are a little high, so let's cut this down a little bit to 1. So now we have a much more clean and crisp point cloud. So here we can see we have our very detailed scan that we did. Walking, as mentioned, the device is fearless of featureless objects. So this is a very large model aircraft runway. So when users, hobbyists want to get out and do their flights with drones and model aircraft, this is one of those places where you would do that at. But the beauty of it is that we have fields all around us. So we have our point cloud. I'm going to go ahead and, just like the LiAir X product, I'm going to draw a buffer line. Little profile line across here. Let me change this buffer. Put this down to 0.1. Redraw that line. For easier visualization, I'm going to put this as intensity, and I'm going to choose a really bright color so that we can easily see the ground here. So here we have a very detailed terrain, we can say a detailed terrain map of just point cloud. So I'm going to come in here, get a little zoom in done. I'll go ahead for this purpose, make the points a little bit bigger so that we can see it with better visibility. And we'll go ahead and do a measurement. So we'll say at its skinniest spot is less than 1 centimeter. Let's go ahead and come over here to get a different spot that, or actually along this runway. Less deviations in the ground. There we go. Okay, so let's take a look at this again. So over here, we have still less than 1 centimeter at its smallest. So we'll choose this spot where it's a little bit bigger. We'll just go at it big. Max is about less than still 2 centimeters. So the system is extremely reliable in what we were stating about the overall thickness of the cloud and the accuracy of the system. So let's go ahead and take a look at another point cloud, which is smaller but highlights more RGB. As we can see what I was talking about, that model aircraft there. Let's make these points a little bit smaller. There we go. So now we have this beautiful RGB. Let's go ahead and visualize this after classification. So we got our building classified, we got our point cloud. Another cool function feature with the LiDAR 360 MLS and LiDAR 360 is we have this Link 3D, Link GS. We can link the point cloud together and allow it to visualize the same thing at the same time in tandem. Also, if we want to see what it looks like on just the panoramic images behind the point cloud, we have this visualization feature so we can see the pano, we can see this location before we really had anything set up. Beautiful point cloud, beautiful classification results. Now let's look at something else with the LiGrip. So this one I will actually open up in LiDAR 360. So here we have some force data that was captured, not at this location, but we can just highlight that here. Some beautiful force data. Let's see, I believe this has tree ID. Yes. So let's go ahead and get a good visualization of this data. Let's go ahead and view this with the cross section. Just taking a look at the trunks themselves. So go ahead and let's remove those canopies. Let's take a look at those trunks. Beautiful, easy to measure, easy to utilize. In the TLS function, we can do DBH measurements. We can run DBH. Something I can, good. Okay, and so yeah, so processing times are usually about one to 3. So as we can see, the SLAM and the filter has already finished. So if we wanted to visualize this point cloud after processing in LiDAR 360 MLS, just the SLAM results, we could do that now. but because I chose filter, it's going to colorize. So what we'll do is we'll go ahead and look at the LiGrip Industry Solutions. All right, so what I was just highlighting is that side of the forestry module. So with the LiGrip device, one of the key functionalities when it comes to forestry inventorying is collecting DBH. So the LiGrip H600, O2 Lite, both can scan stands, large areas of forest land based on the digital green soil LiDAR 360 forestry module. It can quickly count the number of trees, individual tree positions, tree height, crown width, DBH, and tree species in stands, areas, and forest lands. The software allows for a manual marking of species, and then from there we can run an estimation or a biomass calculation based on preset models based on North American data. So we have over 70 different tree models that we can generate from birch to cedar to eucalyptus, willow, elm, pine. And here we can see that we have our tree database file highlighting each of the tree IDs, their locations, the diameter at breast height, the crown area, the crown volume. We have the straight and curvature. Also, if you were to put in the tree species, we have the tree species. Some of the key things that the software and the hardware is being used for at the moment is the protection and archiving of ancient buildings. After scanning the building, the LiGrip device uses MLS or CAD to draw plan elevation drawings, and MLS can be used to further generate mesh for surveying and mapping. As we can see over here, we have our the point cloud being visualized there, and then we have the overall point cloud visualization at the top. We have this building beautifully edited and vector lines drawn as needed. We also have the surrounding vectorization of the building, so the building footprint, all within LiDAR 360 MLS utilizing the LiGrip series. Another key function that can be possible with the LiGrip series is getting volume measurements. So if you have stockpiles that you need measured, you can easily walk around these stockpiles, gather the data, generate the results and the reports with inside of LiDAR 360 MLS volume measurement and issuance of reports so that your users or your end deliverables can be delivered, and these factors can be taken in when doing calculation estimates for total volume and output. In the software as well, we can do building digital twins. So for smart cities and spaces, LiGrip generates high precision 3D urban models and builds spatial digital bases such as BIM modeling. It supports automated modeling, infrastructure monitoring, e.g. rail transit and urban environments, urban planning, environmental analysis and flood simulations, and traffic optimization for smart cities. It allows for precise city planning with lower budgets. The high precision achievements data constructed by LiGrip provides centimeter level positioning and real-time updated channel maps for low altitude vehicles, ensuring safe navigation in complex environments such as cities and warehouses, thereby supporting the construction of accurate waterways in logistics, inspection, and other scenarios in low altitude economies. Fire accident site investigation. After a fire occurs, the LiGrip can quickly capture point clouds and panoramic data at the scene, which greatly facilitates firefighters quickly understanding the fire site structure and evacuation routes. At the same time, the collected point cloud, 3D GS, panoramic mesh, and other achievement data can also help disaster investigators conduct comprehensive, in-depth analysis, mapping, and can also be used for fire education and training. In terms of powerline inspection measurement in no-fly zones, the H600B can be scanned to collect point cloud data, and the LiPowerline software can be used to adaptively filter and separate the wire point cloud, fit the catenary line model to calculate the sag, and generate safety distance reports. The O2 Lite breaks through traffic restrictions through the fusion of feature-free environments, mapping, and high-precision SLAM, achieving efficient and accurate measurements of complex areas and solving data acquisition problems. Topographic map repair surveys. By correcting data blind spots and errors, terrain repair survey provides basic data for engineering, disaster prevention and control, and urban construction. Although existing drones are fast, they are subject to flight bans, high cost scheduling, airspace application restrictions, and building obstructions. The lightweight design of LiGrip supports individual operation, realizing all terrain, high precision and rapid measurement, and high accuracy and no need for retesting, effectively solving the difficulties of complex scenarios and in greatly improving efficiency. Full scene, one person operation, no rescan needed. And finally, underground space information collection. Handheld SLAM is becoming a trend for measurement in GNSS-free environments, and LiGrip is different from other brands of lightweight handhelds, which has the advantages of high accuracy, low drift rate, and small misalignment between multiple floors, which can better meet the accuracy requirements of underground space collection, as highlighted here with this parking structure. Low drift rate, high accuracy, worry-free, multi-floor scanning. Real estate surveying and mapping as well, due to the convenience of measurement and accurate data of the LiGrip O2 Lite handheld SLAM scanner. It can be widely used in property surveying and mapping, asset inventory, and project settlement audits. For multi-level properties in real estate, LiGrip's multi-floor accuracy makes it stand out among many handheld SLAMs, eliminating the trouble of splicing and adjusting parameters. Make point clouds work for you.
Thanks for Cody. Thanks for your very detailed presentation.
Of course.
Yeah, and as the same, we will now take a 5 minutes break, and feel free to drop your questions in the comments, and we will be back shortly with our next product, the LiMobile mobile LiDAR scanning system. See you later.
For the advancement of civilization, we explore geographic boundaries, planning the path of the journey. We detect risks hidden in the unknown and turn nature's guidance into a blueprint, doing our utmost to explore the planet's courses for sustainable development. What are we striving to do? To simplify complex mapping, to explore technological boundaries, to build a sustainable world and shape a better future. To achieve our goals, GVI has invested heavily in cutting-edge technology and R&D over the last decade. Our global branch offices and sales have grown by leaps and bounds. We are constantly exploring new frontiers and pursue excellence in everything we do. Our past has led us to where we are today. Our 4D scanning and modeling, UAV mapping, laser scanning, data processing and analysis, as well as GIS mapping, are among the most advanced and reliable in the market. We provide complete turnkey solutions for a wide range of industries. LiDAR 360, our point cloud post-processing software, is used by customers in over 137 countries and regions worldwide. We generate inspection reports for power lines and create digital twin representations of real world, those to generate reliable information for infrastructure lifecycle planning. This is what makes our LiAir and terrestrial series systems very powerful tools. Our LiAir LiDAR system can be used to inspect all potential safety hazards in a customer's power system and aid in the preservation of the sustainable development of ecological forests. This safe and efficient automated inspection solution can also be utilized in diverse complex geographic environments. The LiBackpack LiDAR system can create a high-precision point cloud to help build smarter cities. in-vehicle LiMobile LiDAR system overlays high-resolution maps onto urban roads. And our handheld LiGrip LiDAR system, a compact yet powerful tool, can adapt to complex construction scenes. Our efficient turnkey monitoring solution is also suitable for disaster investigation and emergency response, allowing early warning and scientific assessment of outdoor operations and disaster situations. This is who we are, GreenValley International, the explorer of the digital earth, striving to make cities smarter, roads safer, and ecologically more sustainable, all while contributing to the overall health and well-being of our planet. For the advancement of civilization, we explore geographic boundaries, planning the path of the journey. We
OK， 满电都有是吧？这线他妈太硬了。开着呢啊，开着呢啊，是。
哎，这个灯没有绿。
有绿灯，浅绿，就是阳光下你看不见。
哦，对对对。
一会儿你先上是吧？
对对对，我先上。好好。喂 ，test test。Welcome back, everyone. And last but not least, the final of our today's showcase, the LiMobile vehicle-based LiDAR system. This is a solution purpose-built for high-precision mapping, smart city digital twins, and large-scale 3D mapping. With the slogan "Smart Mapping on the Move, Limitless Possibilities," LiMobile takes street-level scanning to next level. So Cody, please take us through the product details. Cody. Come on, Cody.
Yes, yes, yes.
Yeah.
Thank you so much, Louise. You hear me? Solid. Thank you again, Louise, for that transition period. Now we will move on to our LiMobile M2 series, precisely capturing the world intelligently and shaping the future of mobile mapping. Our product information is going to start with our LiMobile M2 and then our LiMobile M2 Ultra. I will highlight some of the key functions and differences between the system, and then we will go ahead and do a demo of the LiMobile M2. Key highlights: measuring further and supports Regal model. The Hesai XT32 M2X is utilized with our LiMobile M2 twice. So 32 channels, 300 meter range, 1.28 million points per second, utilizing the dual return. Multiple shapes and freely optional. Users can freely choose external sensors such as Ladybug 6, Ladybug 5, planner cameras, and also DMIs and others. It's highly integrated, flexible installation, supports multiple angle installation, can be adjusted from 0 to 45 degrees in the horizontal position. It easily handles complex scenarios utilizing high precision mapping. GNSS plus INS plus DMI plus LiDAR SLAM is a total package system allowing for almost undefinable capturing processes. Instant insight and total control utilizing the newly designed GreenValley app. Easy to use with real-time monitoring of data and location. AI-powered applications such as our AI algorithms enable its wide use in road asset surveys, urban power surveys, and urban landscapings. So some of the key functions and differences between our previous models and the successor, the LiMobile M2. The range is one of those key things. The LiMobile M1 utilized the Hesai XT32. Only had a range of 120 meters, which we can see displayed on this screen here. On the left-hand side is the California Bay Bridge at the center point. We can see that the M1 was unable to capture the entire tower structure, where with the M2, we easily were able to capture the entire tower structure. Same with the bottom left and bottom right. We have towers or buildings that are stretching much higher than 300 meters, but we were able to capture much higher levels of the buildings with the M2 compared to our LiMobile M1. Again, as mentioned, multiple shapes and freely optional. So we have the planner camera, which allows for pavement camera focus on road surfaces for a detailed pavement analysis, and a front camera captures traffic signs at a high resolution. We have the Ladybug 6 option as well, which supports Ladybug 6, 72 megapixel, obtaining high resolution panoramic images, and our self-developed DMI provides assistance when satellite signals are blocked or unavailable, improving system stability. So just highlighting that captured clearly difference, the Ladybug 5 Plus here in the middle, we can see these traffic cameras. The quality of resolution from those traffic cameras was good with the 5 Plus, but not as good as that of the Ladybug 6. So upgrading to the Ladybug 6 gives us better resolution in our images and also leads to better AI algorithm feature extraction. The system can easily handle complex scenarios. So the comparison of trajectory data effects before and after configuring the DMI. On the left-hand side, top left side, we can see the routes with the DMI and the resulting effect from that situation with the DMI. This is an area that has large buildings and lots of tree coverage where GNSS signal may be blocked or completely lost. Utilizing the DMI, as we can see on the bottom, that same situation now has a corrected point cloud because the DMI was able to correct for those GNSS failures. Same situation in terms of GNSS denied environments, comparison of trajectory data effects before and after configuring LiDAR SLAM. So on the top left, we have the details of an underground parking garage using the system prior to processing the SLAM. We can see that the trajectory is pretty much all over the place because in a GNSS denied environment, it is very difficult for a mobile mapping system to operate without functions like SLAM. In the bottom left, we can see that that trajectory has been corrected with our SLAM algorithms to lead to a perfectly placed underground subterranean garage without GNSS. So the system was able to operate purely on SLAM, making it so that the LiMobile is a multi-platform capability. Easily handles complex scenarios such as heavily dense forest areas, heavily tall building infrastructure such as downtown urban environments, very large tunnels such as like 1, 2, 3, 4, 5 kilometer tunnels, and also, as mentioned, the underground parking garage. We had highlighted the fact that the system is highly integrated and has a flexible design. So our new base allows for a multi-angle installation and can be adjusted from 0 degrees to 45 degrees in both directions of the horizontal position, allowing for sidewalk and asset extraction based on horizontal positioning. Instant insight and total control inside of the new developed GreenValley app, supports real-time preview of point clouds and images, and import of planned trajectories in blue. It is recommended to divide the trajectory according to the survey area, of course. The system supports display of real-time acquisition trajectories in red. It supports trajectory playback in purple, offline map downloading, real-time monitoring of equipment status, and process-based acquisition steps, simple and easy to learn. And it supports a voice device feedback. So in real time, the GreenValley app is generating feedback based on the GNSS coverage, the PDOT value. All of this is a real-time voice feedback, allowing the driver to constantly pay attention to the road and have to worry less about the system status being visually checked. So again, our LiMobile M2 versus our LiMobile M1. The LiMobile M2 utilizes the Hesai XT32 M2X, which has a range of 50 centimeters to 300 meters, and our LiMobile M1 has a range of 5 centimeters to 120 meters. Our Regal Vux 1HA version, which is the LiMobile M2 Ultra, has a range of 475 meters, so we can push that distance out to 475 meters. The panoramic cameras on the LiMobile M1, the only option was the Ladybug 5 Plus. With the M2, we have both the 5 Plus and also the Ladybug 6. In the M1, we did not have pavement cameras, we did not have front cameras. So now with the M2, we have these pavement cameras and front cameras for better AI feature extraction. Now also with the M2, there is a camera trigger mode which allows for time and or distance triggering, where with the M1 it was only allowing for time triggering. The capture time of the M2 is increased by at least 2 hours based on the generated power supply that we provide. The M2 Ultra is about 3 hours just because of the energy that's required to run the Regal Vux. But this system also allows for AC input, so a user can use an additional power supply if needed, including the car's battery. The system structure is ARM, where the system structure on the M1 was 86. And the acquisition software for the M2, as mentioned, is the GreenValley app, where previous versions were web-based, utilizing an Ethernet connection, which may lead to the drop of signal. The processing software for the M1 was LiGeoReference, and then brought into LiDAR 360 for post-processing, where the processing with the M2 is all handled inside of LiDAR 360 MLS, making it extremely convenient to transfer from pre-processing to post-processing. Some of the key functions or features, specifications of the LiMobile M2 is its total power consumption. It also has a data storage of 1 terabyte individual hard drives. It can operate in temperatures minus 10 degrees Celsius up to 50 degrees Celsius. Camera specifications, as mentioned, the Ladybug 6 adds an extra 30 to 42 megapixels to the device, getting better quality resolution at 5 frames per second. And then also the pavement cameras are 24 megapixels split between the two at a 5 frames per second and a 3 frames per second. As mentioned, the LiDAR specifications, it uses 2 Hesai XT32 M2Xs. One of the Hesai systems is used for the actual mapping, where the other secondary horizontal Hesai XT32 M2X is used for the SLAM. The range accuracy is plus or minus 1 centimeter, and it has that range of up to 300 meters at 1.2 million points per second on dual return. The LiMobile M2 Ultra specifications, sensor weight is around 18 kilograms, same storage limit capability, only operates at temperatures up to 40 centimeters, but the absolute accuracy is a little bit higher at 3 centimeters. Same camera options, and in terms of the LiDAR specifications, it has a precision of 3 millimeters, which allows the use case for pavement analysis and other very detailed analysis of pavement structures, road analysis structures. It has a horizontal field of view of 360 degrees and a max range of 475 meters. The workflow. So in terms of preparing for your workflow, the LiMobile system is something that you really need to factor in. Because every environment, every city is different, it is best to understand the workflow area to the best possibility. So do field investigation up front. Investigate actual traffic conditions of road sections to be measured, including but not limited to traffic congestion under objective conditions, such as high traffic time during commutes and or outside of commutes, vehicle speed limits, whether both main and auxiliary roads can be collected, and traffic restriction conditions. Investigate the satellite signal reception in survey area. The equipment's initial navigation, initial position needs to search for more than 15 satellites. So make sure that you take this into consideration when you are doing the INS calibration. It needs to have a strong satellite coverage both at the beginning and at the end. Determine the scanning range and objects. Specify the number of kilometers to be scanned, road type, and number of lanes, which we can provide a sheet that states how big the file storage or file size will be based on the length of the scan. Mark and make corresponding prompts on the map, such as direction of driving route, turns, connections, and etc. Find relatively suitable locations for setting up base stations and plan a certain number of target points. In terms of target points, for all data collection across the board, it is always suggested to get good ground control points. This just helps check accuracy and make sure that elevation and XYZ is as accurate as possible. So correct the positioning error of the equipment, reduce the impact of cumulative error on measurement results, and thus improve the accuracy of the data results. This is an indispensable step on the operation. In terms of control points, the target types that we suggest are road marking corner points, such as the road markings themselves, crosswalks, lane lines, things of that nature. High reflective spray paint points that you can do manually yourself if the city or the road management allows that. And then or crosswalks and zebra crossing points. The layout specification, the target points should be appropriately encrypted in places where the satellite signal will be lost. So control points are best set in areas where you know you will lose the GNSS coverage. That way you can correct the data based on those situations. Surveying instruments are either RTK or total stations. On the bottom right hand side, we have a description of the way that target points should be set out based on their situation and how far apart each of those control points should be. On the left hand side, on the bottom left is the limited sky visibility. So in limited sky visibility, it is best to do control points within 50 to 200 meters of each other. In a tunnel, it is best to do those control points 50 to 100 meters between each other. In open sky, depending on what the range is for satellites, you can move between 100 and 500 meters. Driving route planning. So considering the issue of point cloud sparsity, for two-way 3-lane roads, the vehicle must stay in the middle lane. For two-way 4-lane roads, 2 passes in each direction are required to collect sufficient laser point clouds. For two-way 6-lane roads or more, multiple passes in each direction are required to collect sufficient laser point clouds. Considering the issue of occlusion by median strips or green belts in the lanes, if there is occlusion, two-way lane roads require 1 pass in each direction. Considering data accuracy requirements, prioritize straight road collection. Avoid turns, loops, lane changes, and to stay straight. For roundabouts, fully cover by driving once in the innermost lane. For overpasses, fully collect all ramps. First straight along the main line, then each ramp separately. Data collection and processing workflow. Starting with capture, utilizing the GreenValley app and the LiMobile system, having all of everything set up, you want to set up your base station, device is powered on, connect the device to the system, allow the initialization to occur, start the recording, data collection then presumes. At the end, you'll stop the recording, you will do the final INS alignment, and then the device can be turned off or continue the collection. Then you will do the processing with inside of LiDAR 360 MLS for georeferencing, post-processing, and also colorization of the point cloud. Then in LiDAR 360 MLS's post-processing side, you can do the feature extraction, including utilizing our AI algorithms. And then to share this data, we do now have a platform which is cloud-based called LiShare. You can easily share a URL to highlight the indeliverable result. Now we will highlight just the base station setup. Stable ground for easy setup and operation, set on known points with measured instrument height, open view obstacles with an elevation angle 10 to 15 degrees to avoid satellite signal interference, no strong satellite signal reflectors nearby such as large buildings, stay away from high-powered radio transmitters, full coverage of the survey area, so a max distance of 20 kilometers for accuracy in between each of those base stations, and setup time covers data collection. So making sure that you collect base data for 15 minutes before and 15 minutes after the ending of the collection. Choosing multi-band compatible base stations such as our LiBase or others that allow for 3 satellites, 7 band, full satellites, full band for stable connections in various environments. LiDAR 360 MLS's LiNav does now support the multi-base station calculation process. Data collection notes. These are some of the key factors. So sudden braking is prohibited, sudden stops and movements are avoided, minimize the number of stops while driving. When you need to pass through a tunnel, you should speed up. After the acquisition is completed, please make sure to click the shutdown button on the app interface first and wait for the device to shut down before disconnecting the power supply. Do not turn off the power supply directly as this abnormal operation will cause data loss. Do not unplug or plug the data collection disk while the device is connected to a power source. Try to drive at a constant speed throughout the data collection time, and maintaining a constant speed of 40 kilometers an hour is the best practice. Be sure to perform IMU alignment operations as this is absolutely critical for good data. Post-processing AI functions, which we will highlight some, is the AI-based pavement damage detection, plate and face blurring, road marking extraction, and road facility extraction. And now we will walk through a live demo of the LiMobile M2.
Let's go, Cody. Our product manager has prepared this for us. Thank you.
Yes, thank you, sir. Thank you, sir. It looks so beautiful.
Yes.
So, I mean, pretty much from start to finish, obviously we need the car. So we have ourselves this rented car here, ready to go. From bottom to top, we have our custom designed DMI, which is suited specifically to the tire's dimensions.
What's the DMI used for?
So the DMI is a distance measurement indicator. So what it does is it calculates the amount of distance running as the car is operating. In case there is situations where you lose GNSS, our trajectory can still pick up even though we don't have GNSS.
In the tunnel?
In the tunnel as well, yes. So in the tunnel would be the best case use for the system because you have 0 GNSS. Tunnels might be long, so slant processing might also be long. So utilizing the DMI is the quickest, easiest, and lightest bit of data usage for that.
Yes, perfect.
So yeah, so we also have our roof mounted system. So as mentioned before, we have our base mount, which comes with the product itself. We have legs to make sure that the system stays as stable as possible. We have our easy pop on, pop off mounting base plate, which allows for the device to turn, as mentioned before. And then we have our cables and operation for us to be able to set up the device.
Cody, I noticed this. The M2 can switch.
Yeah, so if we just unscrew these, it allows for us to be able to easily spin out the device itself. So as we were mentioning in the acquisition, we can turn it up to 45 degrees in both directions, which will allow the sensor to face this way, capture everything that's down here very easily, face this way to capture what's needed here, and then also face this way to capture this side of the road.
Yes.
So in this case, we'll go ahead and set that back into place. Nice and easy. Locking in place to get us ready for this collection. Good to go. All right. So in this case, we have our locking mechanism. So we'll come back over here to look at the device itself.
Okay.
So from left to right.
face to the camera, please.
From left to right, I'll actually stand behind it. So from left to right, we have the actual LiMobile system itself. We provide you with a tablet for the operation, which has the GreenValley app embedded into it, and we have our LiMobile M2. We have our standard Hesai XT32 M2X and another XT32 M2X here. This one is used for the actual scanning. This one is used for the SLAM corrections.
Oh, this one is used for mapping, and this one for SLAM?
Exactly, yes. So this one is the one that's constantly running for the mapping purposes, and this one is used to correct in the cases of like the parking garage that I mentioned.
Okay.
And in this version, we have our Ladybug 5 Plus with the GNSS antenna built on top.
Do you have other model of M2?
Yes, so we also have our LiMobile M2 Ultra, which the only difference between that system and this is that it utilizes the VUX1 HA sensor to provide that millimeter level data. And then from left to right, we also now have our new battery pack, which the system is designed to couple with our new released self-developed batteries, including operational power on and off, which will power on the device and power off the device automatically. It has a LAN input, a DC input, or a DC out and a DC in, and also an AC in for that external battery source that I was referring to. And we also have our planner cameras. So we have designed planner cameras both for pavement detection. We have planner cameras for front facing and also for the side. So it can be the spider effect to get a good planner camera angle from every view.
The front camera is used for
like detecting signs, road markings, things of that nature with
facilities.
Road facilities, and so for our AI algorithms, it works best.
Electricity, MLIS.
Exactly. So the AI extraction features work best with very high quality images that are very detailed and straight on. So capturing road signs, the ones that you pass through, with just a hyper focus from that, it's best with those planner cameras.
Perfect.
Then we have our provided tool, which allows you to easily assemble the system without issues. And then also our...
What's this?
This is our self-developed data copy drive. So this allows you to have power and the data, then 2 slots. So I said that there's 2 1 terabyte drives. One is specifically to store the panoramic images, and the other one is designed to store all the other data. So with the 2 of these plugged in, you can easily pull the data directly off the device through MLS. So MLS will actually focus the data transfer, allowing for data check as well. So so it'll allow for an accuracy check of the data right off the bat. So it'll determine whether or not you have all the data that's there, everything that's needed, and run a complete check for you while it's doing the copying, so that when you go to do the process, you know that the system has everything that's needed to do the processing.
Okay, perfect. So we can install the device?
Yes. So the very first thing that I'll do is I'll go ahead and take the system
it's a smaller antenna.
Yes, very small antenna.
Yeah, if I want to add the big antenna, it's supports?
Yes, we would just need to do the calibration for it.
Okay.
Or we just need the parameters for it.
Okay.
So here we have our system, super easy to put up. Just slides on here.
It's also super easy.
Super easy. The system is already locked in place. And just to verify that we have it locked and that it stays as tight as possible, we have our twist screw knob, which you can, for safety purposes, tighten either by just hand, or we also suggest utilizing the tool, so the Allen wrench. Next, what I'll do is I'll go ahead and attach our planner camera.
This camera is for pavement capture?
So this camera just goes here.
So make sure plug the cable firstly, right? This cable firstly, plug in the cable firstly, and then mount the camera.
Okay, so this plug goes into cam 2. So on this side of the device, we have 4 different cam slots. Cam 2 is specifically for the pavement camera. Cam 1 would be for the front-facing camera, and cam 3 and 4 would be for the side-mounting cameras.
Okay.
And so from here, we'll go ahead and put this in.
Maybe you can use our provided tools.
Yes, but by hand first makes it easier than trying to put this on, and then we'll go ahead and just screw this in. like so.
So, equipped with the pavement camera, what kind of analysis can I do?
Yeah, so you can do pavement analysis such as detecting cracks, detecting potholes, rutting, pretty much anything that is industry standard to make sure that roads can be as safe as possible without any issues. And that can be done by AI, and you can have those annotated with individual information such as the location, size, all those can be captured utilizing the cameras.
Deeps based on our point cloud data, right?
Yes, yes. So it's a secondary factor, having the point cloud and the images to allow for both point cloud and image-based AI classification and feature extraction.
Got you.
So now that we have established and attached our pavement camera, the next step will be to attach our battery. I'm just going to slide it through.
Yes, you can.
Actually, I'm going to pull this back out and show you.
Oh. The cable.
Yeah. So we have our two antennas. These are designed for transmitting the signals to the device. And we have our two power cables. So we have one power cable and we have our LAN cable to the battery. So LAN plugs into the LAN port and power cable to the battery. One of the things that GVI has hyper-focused on is the use of LiMo cables. They're very reliable.
Oh, yes,
they last a long time, and the red dot function allows easy use and easy port input. So this would be DC out.
How to open all the batteries at the same time?
Yes, so at this point we would be able to turn battery on, and then that would allow for all the batteries to turn on at one point, which I can go ahead and do now.
Okay.
But no power.
You didn't connect the device.
So make sure that you come over here and plug in all of the cables. So the first thing that I plugged in there was the DMI cable. And then next I'm gonna plug in the LAN cable. And then now the power cable, and this should allow that button that I just pushed to work.
Yeah. You missed the most important
part. You'll start your collection and get nowhere. Okay, so back to the battery power function. Now I will go ahead and select battery power on and wait for the batteries to turn on.
I think you bring the wrong battery. Maybe it's
batteries.
B58.
Yeah, these are the
B60.
Yeah, these are the B58. So these ones can still be used, which are the previous versions. So by turning battery on, I still just need to power these batteries on.
Yes. I think you need to change to the newest version of our battery, B60.
Exactly, yes. So the
but
B60,
you still can open it manually.
Exactly, yeah. The B60 is the intelligent battery, so that's one of the key functions with the M1 to the M2. Is, now
for the standard package, we will provide customers with the B60 batteries.
Exactly, yeah. Making it so that they can, by one touch operation, both power on and power off the batteries instead of doing that individual operation that I just did there.
Yes, exactly.
Making life a lot easier for the user.
Yes.
So in this case, what I'm going to do is go ahead and slide this battery pack inside the window.
Okay. So next you will show how to collect the data?
Exactly. So next we will go ahead and get in the vehicle and show how to collect the data.
Okay.
But first I'll power this on.
Yes. Hi director, please focus on. Or you want to show it on the car or? Okay, let me check. Maybe you can get into the car firstly and then.
Go here.
Yeah.
Now we wait for the remote to turn on.
Okay. See you later, Cody.
Okay, bye-bye. Thank you, Louise.
Bye.
It appears there may have been a software update. classic real world demos. Software update.
So maybe we can introduce the device or...
Yeah, I mean, so as this is waiting, we can go ahead and talk about the device itself. As of now, the device has been fully powered. What we can do is prepare for that. So in this situation, we would make sure that we are ready to do our INS calibration alignment. So if we are at a location that is not suitable, we will drive to a location and find that suitable spot for that. So normally we would set up at that location, but sometimes setup is only possible in one place, but you could do INS calibration at a different place.
Did you set up any base stations?
Yeah, so we actually set up a base station similar to what we did for previous projects. We make sure that the base station has been set up. We collect GCP points also as well, making sure that everything is going to be perfectly aligned.
So the LiMobile usually we recommend the PPK to prove our accuracy, data accuracy.
Absolutely, yes. Also coupled with GCPs. So also always suggest collecting GCPs. As mentioned before, the GCPs are best captured on very clear objects. So road markings, crosswalks, lane lines, lane markings, left lane lines, the tip of them, very good because they're in the point cloud as you're driving by. So instead of setting up a control point on the sidewalk or something where the vehicle may have a hard time seeing it, say there's a car next to you, the point cloud should always be able to pick up road markings because they're on the road. So it will see it whether it's before or after, it'll capture that data that's needed. So
maybe you can use our computer connection to the device or wait for or use your phone?
Just a little moment.
So the tablet is upgrading?
Yeah.
Maybe we can drive firstly and then show the app during your connection?
potentially, yes, yeah, it's at 94%, so I think we're pretty much almost there.
Oh, that's great.
This is very normal though in a real world situation. The app update is always going to release as soon as you get in the car.
Like Windows system.
Exactly. Like Android, as soon as you get in the car, the app, the update is going to be requested. So
yes.
you want to make sure that even if you do it at the office, you double check before you go to do the collection.
If the system has been upgraded.
Exactly. Yes, because it's bound to happen when you're trying to do the collection itself.
Yes.
So almost there.
Almost there. So our GreenValley app was based on the Android system, or?
Yes.
Oh.
It's an APK version.
Oh. Still in process. So now I heard we have a new version of M2.
Indeed.
M2 Pro.
Exactly.
Do you want to share any details of this new version?
I don't know how much I can share. But yeah, so the new LiMobile M2 is designed to be more cost effective. The sensor itself is a little bit cheaper. It also has a different camera, providing the same 72 megapixel resolution at a much lower cost. So the results that we are seeing are extremely promising. And I'm excited to say that hopefully will be released extremely soon, real soon.
Yes, very soon.
Very soon. Maybe they'll have to come and visit our booth at Energio.
Yes.
That could be
important details.
Exactly. They can get hands-on with the device at Energio.
Yes, now we...
I don't even want to touch that.
Oh, yeah.
Okay, so we'll open up our GreenValley app. There we go. That
here you
extra
go.
3 minutes of time.
Connected successfully.
As I had mentioned before, we have a real-time voice device feedback. This is very critical for the driver. The driver should not be taking their attention off trying to watch the interface of the app. So we have our GreenValley app. From top to left, we can see the device that's being used. We can see the PDOT value of our location, the real-time 4D satellite signal that we're seeing, we can see the operating temperature, the battery, and we can see all indicators are stating that we are green and we are good to go. On the left-hand side, we have an offline map download, which allows us to preload in a map or draw a map on a base map and then load it into the system. So if you don't have coverage out in the field. We also have our track manager, which allows us to see the previous known projects. We have our sensor parameter settings, so navigation, panorama, and planner. We can see all of the functionality of these systems. If we had multiple cameras, we would see that it says front camera, left camera, right camera. Right now, we just have rear camera selected, and we have the frame rate selected. In terms of panorama, we can see the panorama that we're going to do it by time and frame rate 2 frames per second, and the data format stored is as such. We can see our calibration file and also the firmware versions for software, for the app, and for the system itself. We have our log file, which is what indicates whether or not the system is in good status, and while the operation is occurring, we will see a real-time log of every bit of the system in action. And then we have our frequently asked questions. So if there's any questions needed that we have already set up for you, you can just click on it and it'll show you those in real time. So we'll go ahead and close that. So it says, before creating a new project, click the settings menu left side to complete the configuration parameters, such as the navigation, which we did. So we don't have to worry about that. So over here, we can see that the device is already capturing a real-time LiDAR point cloud. It's collecting in the background, and the panorama and the planner are also generating feed. So we can see we have our planner images facing downwards for the pavement, and then we have our 360-degree camera. This is allowing us to see what's happening in real time. Same with the LiDAR, we can pull it up and see that the LiDAR itself gives us that real-time visualization, and our pavement cameras as well, we can see our pavement. So from here, what we'll do is we'll go ahead and hit play. Actually, I'm gonna take that back. Let me close out this window first. Now we'll hit play. I'll create the project, just say demo, with demo. Hit OK.
Project created successfully.
Now the first thing that it says is IMU alignment.
Installation has been completed.
So what we're going to do is a static alignment.
Aligned according to the specified procedures.
The voice feedback as mentioned. So we have a static alignment. What it states is please remain stationary for 3 minutes in an open area, which we will for the demo move on past that. So what I'll do is I'll hit OK, which will move us to the dynamic alignment. What this is we need to do a specific procedure in order to get a good dynamic alignment. So it says at least 2 straight line acceleration and deceleration driving, and several heading changes, left, right turns, and U-turns. The distance should be more than 200 meters for the total dynamic calibration. But in this case, since we are just doing the demo, I'm going to hit OK again. And so this states IMU alignment is completed. Please click right side to start recording. So what I'm going to do is hit this play button. And now the device is successfully starting the recording. As we can see, a real-time trajectory is starting to produce in the visualization of the point cloud. We can see our panoramic images are starting to adjust and change. So we have our front-facing camera. We have our rear-facing panoramic camera, and now we can take a look at these pavement cameras. This is how we're going to get that really fine, detailed analysis from the pavement cameras. See each individual crack from the individual camera itself. There's two of those dual cameras. Here we can look at the real-time LiDAR point cloud. Again, we can center it. We can rotate it so we can start to see this building over here to the right of us. We got a building. We'll put it back center. We'll close this. And we can also see this real-time trajectory that's being generated. If we had preloaded in a base map here, we would see the actual base map and the location as the trajectory is following. We can see the distance that we have gone so far is about 1.1 kilometers or 14 meters, 140 meters. The speed that we're going right now is about 8 kilometers. We can see the system disk, the panoramic disk. We can see the header at which we're going. We can see the pitch, roll, and yaw, the latitude, longitude, and the height. We can also see that we just went over a bump and the pitch and roll was able to adjust a little bit there. And as mentioned, we have a log. This log is showing us that all devices are recording correctly and started start collection. All of them are operating. Everything has generated. The project was started correctly. So we can see these pano cameras just continuously adapting and changing in real time. This beautifully hot day and some water. Take a look at that in the planner camera. So real muddy. We had a terrible storm here yesterday. One of the worst that I've seen actually in a very long time. So I'm happy that it didn't heavily destroy our demo location. So as normal, what you would do is you would go to any location. The beauty of the LiMobile when using the SLAM, it's considered a local SLAM. So it doesn't actually need a closed loop in order to use the optional SLAM function. So you can start at one location, drive to the other side of a city, and close your point cloud collection there if that's what the daily needs are. So here what we'll do is we'll go ahead and stop and end the collection at the location we're at. So what I'll do is, if I wanted to though, that I didn't mention there, we do have a pause play function here. What this does is pauses the recording. The trajectory will also still keep recording. So say you're in an area where you hit heavy traffic and it's stop and go and you got like 20 minutes in one position. No point to collect a bunch of LiDAR data and photos of the same exact place. It's just going to be redundant data. So you can pause that. The trajectory will keep going so it knows where it's at if you slowly, worm along. So that pause play feature is a beautiful function. So, but in this case, we'll start the play again. So now we've started the recording again, but since we've reached our destination, we'll go ahead and hit stop. So it says, should collection be turned off? And we hit OK. So same procedure, but in reverse. So at the beginning, we did static alignment first, and then we did IMU dynamic alignment. On the way back, so after you've finished your collection, you will do the dynamic alignment first. So it's best to do that dynamic alignment in an area that's going to take you back to your location, making sure that you have appropriate satellite coverage the whole time. And then you'll run this operation of dynamic alignment, doing those 2 straight line accelerations and deceleration drivings with several heading changes. Once that has been completed, you hit OK, and then you'll do your static alignment, which static alignment means you're going to sit in the same exact spot for 3 minutes. There's a countdown timer, so at the end of that timer, the data collection has finished. You can hit OK, and now the data has been stopped and it is saved onto the device, which means you can either end for the day or start your next procedure of collection. So that would conclude the real-time visualization of the point cloud and the LiMobile's demo. We're going to go ahead and hop out of the vehicle now. And so we'll make sure that if we're not going to collect more data today, we'll go ahead and power off the device. So please confirm if you want to proceed with the operation. I'm going to hit OK. What that's going to do is shut down the LiMobile, which will allow me to go out and actually shut down the battery pack itself.
Finished, Cody. Finished.
Good stuff. Yes, yes. Just going to put that in the car.
Okay. Let's move back to the stage.
Okay.
To show the data process.
Awesome.
Okay. Director, please switch the camera back to the stage, and we will show the M2 data processing.
All right, so that was a fantastic in-person demo of the LiMobile M2 in working order. So now the next step that I'm going to do is go ahead and walk through that real-time processing of the LiMobile data. For those who were here for the LiGrip data, this is the resulting outcome of that collection that we had done earlier, but I will go ahead and close that. Now we have our LiDAR 360 MLS and main page. So for the SLAM project for LiGrip, we utilize new SLAM project. For LiMobile M2, we utilize the new mobile project. So the same steps and scenarios that I'm going to do is I'm going to go and find the LiMobile M2 data. The structure is the same with labeling roughly about the same. We have this mscan file. So I'm going to go ahead and select mscan and add a new one. So that does the same exact process of steps. It opens up a project folder within the selected directory that we want to choose. And then I'm going to go ahead and import. The key difference here compared to that of the LiGrip is the LiGrip was a LiSlam file. The file for this one is actually a .live file, which is similar to our LiAir products. So the camera structure or the subfolder structure is the same. It produces a base file, a camera raw, a laser raw, LiNav, log, parameter file, raw data report, which is what I was referring to when you transfer or copy over the data, you receive a raw data report that generates during that copy phase. And then we also have the results and the rover and temporary folder. So in this case, I'm going to go ahead and open the .live file. Now we have a LiScan folder or file here, and I'm going to do the same thing. I'm going to go in, I'm going to look at the project settings. Here, compared to the LiGrip, we can see a few differences in the way that it's set up. So we have the laser setting. Here we have the raw data. I'm going to go ahead and put a filter. In this case, just for time reasons, I'm going to choose a distance filter of just 2 to 70 meters. So I'm going to choose start distance of 2 and an end distance of 70 meters. This will allow us to process this data extremely fast for the purpose of being on a live demo. Hit OK. In this case, camera settings, everything is preset based on that .live file, so we don't need to add anything, but we have the camera 3. We also have the Ladybug camera pano set up. We have our POS process, same situation, just the difference is the Rhinex file compared to the Novotel file from earlier. So I'm going to come in here, go to base, and add in the .o, add in the .p. So now we have what would be generated from either a CORS station or something like our LiBase product, generating that Rhinex file for you. Same situation, if you do have the physical absolute point, you can add it in under the manual setting. If not, you can just run with the from header. Same situation with the target coordinate system. It should, based on the loaded base station, preload in that location. Here we have the SLAM settings, so you can preset the SLAM settings if you wanted to process SLAM. In this case, we won't highlight the processing of SLAM because there's no need for it. We are in a completely GNSS rich environment, as we saw 40 plus satellites, so absolutely no need for the SLAM at this point in time. We have a strip adjustment which can be done automatically, so if there is any type of trajectory jumps that may occur during the collection, this algorithm will automatically detect those jumps and adjust the point cloud based on that in the pre-processing phase, so there's no need to worry about doing that yourself. We have our filter setting for noise and for smoothing. Again, for time purposes, I won't choose either of these filters, but the noise filter just allows for a removal of noise off the bat in the pre-processing phase, and smoothing allows for a smoothing of the point cloud. So if there's really harsh edges that really don't exist just because the way that points formulate together, you can do an automatic smoothing. Inside of LiDAR 360 MLS, we have classification built into it, so you can preset the block length, you can set the buffer for each of those blocks, you can set the different type of modes, so we have several different types of modes. We have GVI road, indoor, park, forest, garage, and railway. In this case, we'll just look at the GVI road MLS, and then process type is GPU, classify mapping, and then batch size based on your computer size. Colorization, similar to that of the LiGrip, we have a radius base, pretty much auto masking, and the camera option, we can switch between panoramic or the planner if we decided. And then the mode, in this case, we'll do color by time, and same function of the color, optimized sky colored points. So now that I've made sure that all of the parameters are correct, I will hit apply to all. And over here, just to double check everything looks good, the same as it was, we have the laser, we have the camera settings, and we have the advanced settings. So this would be also, again, where you can highlight the SLAM. The output, we have the filter, we have the colorize, and we have the classify by deep learning. Everything is good to go, so I'm gonna hit OK. And the same situation with our LiGrip and with our LiAir products is that we have this one-touch operation. So any of the functions that you want to see processed, you just go ahead and click. So for the time's sake, I'm gonna do just post-process and georeference. But if I wanted to do everything in one go and not check the data, not check anything, and just end with this fully classified, colorized georeference post-process point cloud with strip adjustment applied and filters, I can click all of these and hit start run, and it will run all of those one by one in sequential order, allowing you to have your fully processed point cloud in a matter of time. For this case, I will go ahead and hit start. And then I will go ahead and open up a data set in MLS, which is actually the same exact data set, but I will just open it up since it's already been processed. And then once this finishes, I will show the same results. So for this situation, I can go ahead and open up the previously collected georeference, or I will just do a new mapping project, point cloud. I will come in here to the LiMobile M2, and I will go to result. And here we have these 3 files. Under the HSI, we will see these 3 LiDAR point clouds. This is the real time. I put them in all in the same one. Okay. So in this case, I will just highlight this data. None of that. So none of that here. Okay, so I'll go ahead and just do the point cloud itself for this visualization and wait till the rest of the point cloud processes. So this is a data set that was captured with the M2 just to allow us to be able to view the quality of the results. And as mentioned when we said control points, we want to make sure that we put control points in situations like this. So if I was to pick a point, we want to choose this point here. A little bit of computer lag. So here we can see we have the XYZ attribute value, we have the intensity value, return number, classification, time, RGB, and source ID, and if there's any other additional attributes, those would be added along with that. And it looks like this one has already processed in terms of the georeference. So this is that data set that we just said we would highlight. So I'm going to close this just to clear up bandwidth. So we have this, I'm going to close it. So now we have this point cloud, which is just the point cloud without colorization. So that took all of 3 minutes to get this point cloud, which was this route that we had just done. Now, what I'm going to do is go ahead and just draw a quick line. Same as I would with the other products to show these double passes. And here we can see no layering, no issues. The point cloud is crisp, it is clean. Do this in a different visualization. So we have a very clear point cloud here. If I set this buffer, we can do a measurement. So we're looking at about max of 0.2, maybe 2, yeah, about 1.5 to 2 centimeters of thickness from this point cloud. The other thing that I can do is just run the colorization. But see here, we have this beautiful panoramic view and then also the point cloud visualized over it. But for time, I will, in that, just do colorize and start that. And we'll see about, I'd say about maybe 5 minutes max for that. So in the meantime, I will go ahead and highlight some industry applications. All right. So the LiMobile has a series of capabilities. It is not just a one-trick pony, as we say. a multi-industry application coverage from everything in regards to urban forest surveying, section analysis, HD mapping, railway safety analysis, all the way to urban power survey and analysis and road safety analysis. Ecological landscape simulations and road maintenance, along with creating digital twins, allows for the holographic digitalization of road elements. Urban power survey and analysis, flexible operations in densely populated urban areas, operations in restricted flight areas, automatic extraction, height limit analysis, clearance analysis, and analysis report. All can be easily generated from LiDAR 360 MLS. A digital twin can be generated, so rapid collection of multi-source data, generate component level 3D real scene with one click, supports automated quality inspection, supports model library expansion and customized configuration of model textures with more than 10 model editing tools. Road safety and road maintenance analysis allows for road maintenance, vehicle passability, section analysis, again, all easily done with one touch operation inside of LiDAR 360 MLS. Leading to, as mentioned, the holographic digitalization of road elements in real-world situations. In this situation, we had a case in Thailand where the road reconstruction and expansion project had a very specific need that the LiMobile was able to collect 111 kilometers of effective data in 2 hours and 21 minutes. Then LiDAR 360 V8 data georeferencing, strip adjustment, effectively reduced data errors and achieved an absolute accuracy position based on about 5 centimeters or less. Even after multiple repeated scans of the area, the data remains in the same position. An urban power survey and analysis in Flemington, Victoria, Australia. The powerline encroachment assessment project. LiMobile was used to complete the scanning of about 7.5 kilometers of power lines in just 1 hour in order to determine power line encroachments and allow for danger point reports to be generated and given to the people who will go out into the field and make sure that they take care of those danger points. The device on display over the past 6 months, we've had the device in Dubai, in Japan, in Australia, in US, and also in China, allowing for us to get a lot of data to allow for that training models to be collectively designed for global use in multiple different scenarios. So our classification module and also our deep learning image detection algorithms can be as accurate as possible. And again, thank you all for being here, shaping the industry ecosystem together with AI. It's been a pleasure. And now I will turn it back over to Louise.
Thank you, Cody.
Yes.
So, hello everyone. From LiAir's air-room precision to LiGrip's ground level
thank you.
to LiMobile's large-scale mapping, all collected through GreenValley's powerful software ecosystem, we truly deliver all-scenario LiDAR solutions. If you would like to learn more, follow us on LinkedIn and YouTube channels or reach out directly. And if you want to today's sample LiDAR data, follow us on LinkedIn or subscribe on YouTube, then send us a quick message or comment data. We'll send you the download link. And our big thank you to everyone watching us from around the world, to our on-site technique and marketing team, and to Cody for nearly 3 hours of non-stop demonstrations. And Louis, thank you for joining us today, and for see you next time for our more demonstrations and product deep dives. Bye. Thank you again.